and put the controls up here. So, did everybody get their data sets and the user's manuals successfully? Everybody got those all right? Or anybody have a problem with it? Okay. Alex and Jason are good.
Good.
All right. All right. So everybody's got all those. And what we have in terms of that is, let me show you where we are here. We basically have these two documents, one of which is the civil training guide. You might notice that's what that shows. And then there is a takeoff tutorial. Now, what that is, and I'll pop it up here and show you. What these two documents are. Let me get this other one over there. Okay, so the training manual that we're going to use for most of our exercises is this Carlson software civil design module. Now that happens to be the same training manual that we use for the civil class, but it has some of the very same exercises and skills that you need to develop to do what we're trying to do with machine control. But we're going to flesh out more of those machine control options and techniques as we go through this. And plus there is a part of the civil software that is geared toward this quote takeoff or machine control type workflows. Now, this other document that is included there, we won't really go through much of this, but to show you what it is, and this is the document that was prepared by Carlson, whereas I wrote that other one, but this has, sort of steps you through, the whole thing, start to finish, how to set up a project. And this document is, oh gosh, I don't know how old it is. It's a bit, let's see here. And you may see it's quite, let's see, it was, back in 2016, well, it's about the same as mine. It was back from Carlson Takeoff, version 9. They're up to version 12 now, I think. But as you can see, this has, how to install the software, how to set up a project, all of this. And so it's because it's got some age on it, it's not exactly there. But the thing about this is that it starts, and it goes through, you notice here's chapter 2, the file menu. And that then starts with new, open, close, save. So what it's doing is going to step you, this is essentially the help system out of the software. So it shows you all of the commands in order, and then you get finally out of the commands. Let's see, now they're just chapter 5. You're up into the draw menu, then the takeoff menu, drill hole menu, and then at some point, it's still in the menus. Okay, so then the displays, BIM, and help, and then this tutorial menus. This is really where the tutorial starts. And there's a couple of things here. There's this, the CAD file takeoff, how to do a takeoff of a CAD file from start to finish, doing road designs, doing drill holes, trenching, and digitizing. So for instance, if we go to this section on the takeoff tutorial, it shows you, start takeoff. And if you don't have the takeoff module, the construction module, or the takeoff software, don't worry about it. That you can just say, well, instead of starting takeoff, you're going to start civil or whatever. But then it shows you that this drawing called Demo 1, and that's included in your standard installation in your Carlson software folder. Okay. So it's going to load this drawing up and step you through a couple of things that are typical with the workflow. So it's a pretty good little installation or initiation rather into the process. And we may load this file up and take a look at it because some of the things are sort of, preconditioned, if you will, as to what it is we're going to be doing. But we're also going to look at some live data, some other stuff that's included with your data sets. Okay, so this really has some pretty good references here as a step by step. Okay, and again, you can see, this is what, 829 pages long. Okay, so that's quite a document, and we're certainly not going to go through every page of that document. Okay, but we're going to go through, take a look at this one, and it's only 147, and it is structured like so. It's got a bunch of upfront stuff, a little bit about me, about the company, about Carlson software, how to organize the work, talks in general about menus and the difference between general and modular menus. That's just like, a page and a half worth of discussion. Then we get into settings. We talk about some settings in basically in a page there, but we're going to go over some of that in the software because it's important to understand what they control, because they're going to greatly affect what we do with the work. And then we go through a couple of items here, these little red entries in the table of contents. You'll see are exercises, and it talks about dealing with points and point groups, break lines, how to evaluate things that become part of a surface. And then there's a little workflow to do a sort of putting all of that stuff together. If I click that note, these things are hyperlinked. They'll jump you to where you need to go. And so this has basically some points that had been surveyed, and it steps you through how to build a stockpile out of that, and then to compute some volumes. And then we dig a borrow pit out of the stockpile and merge the two surfaces together, as you can see down here. And then finally, we design a little access road that comes up into the floor of that borrow pit. And so that, then shows you some of these road design tools that you can do. Now, this road design, if you look at this approach, it basically says, we're going to create a center line, and then we look at the existing ground underneath it. And then next we're going to create our vertical profile against that existing ground. And then we're going to use that to draw a three-dimensional polyline on the ground here in space at elevation. And then we're going to take that and we're going to offset it, 12 feet, 20 feet, whatever that distance is, to either side and down at a 2% slope, cross slope, to get the other edge of that road. And then we're going to tie the edges of that road back into the original surface so that we can get the cut and fill slopes on that road. Now, that's just a very standard, very simple, I guess not really very standard, but very simple approach to road design. And it's just designing the top part of the road. Okay. So, but that shows you some techniques that you can use. Is we're going to have this as a 3D line, and we're going to use it to create those offset edges and then tie those into the ground and come up with this modified new combined slope. And you can see how that road comes up here and then into the borrow pit. All right, so that's what that set of exercises does. Now, when you look next, the rest of these designs are very specifically for civil, and it has some, a lot more complexity to it. So this particular road design, instead of just doing the top of the ground and offsetting the edges, we're going to have a center line that is then constructed. We have this center line on the ground. Oh, for heaven's sake. All right, you guys see that little warning? I have I have the software. I've never seen that before. All right, if we get if we get lost, you guys stay close to your email. I may have to figure this out. Uh, all right, well, let me finish this discussion here real quick. All right, so instead of just being that stuff on the ground, it's going to give us the tools and techniques that we need to generate all of this subgrade materials, concrete curbs, uh, cut and fill catch slopes on the sides. And, so it's a lot greater complexity. And then we're going to learn to do, say, a grading exercise where we're going to have building pads and sloped parking lot pads and how we can handle intersecting those edges that, they may hit on the edges. We're going to look at road net that will automatically compute intersecting roadways like this up here. So we're going to get beyond just that first section in the book that just goes through that little simple road design. We're going to start going into deeper aspects of that. And then we're going to look at the takeoff tools as they apply, from the takeoff product. Now, before we go, and I may have to I'm going to ask you guys to all sit real close to your email. I'm going to have to probably end the meeting and figure out why it put me in the wrong stuff, and so we can get back. We can have our full session here. But from that point forward, at the end of those exercises, then the rest of the book is like those commands in the other book that I was showing you. It shows you all of the individual Carlson commands with things like that you see that are red and bold. Those are things that are just, by my experience, things that I find a lot of good functionality in. It doesn't mean that the others aren't functional. It just means those are very useful. So, just a little thing to sort of remind you. And also notice in this particular set, and this goes all the way through, the whole business of down through the annotate menu. But and again, it's on the in the civil package. So what am I getting to? So, but it doesn't have in some of these other upfront menus, if it's a standard CAD command like draw circle, it's not going to be in here. These are just the Carlson commands. So with that, that should be sort of your guide when you're going through this stuff on your own later on, is that you can go through here, go through these example exercises, and once you get to this exercise, putting it all together, then the next page says civil module exercises. Then that starts the road design and the grading tools. Okay. Then you're going to get to, in this particular menu, SiteNet is the one that corresponds to the takeoff software, which in a lot of cases, that's the software that we're going to be using. Now, real quick, I've got 4 minutes left before this session is going to time out, and I've got to jump back to get on there. Let me ask each of you, what software do you have installed? Are you using the civil and survey modules, or do you have takeoff like R9, R10, R11, R12, or do you have the construction module? What you guys just let me know what it is that you have. Alex, I think you and I have talked, you're evaluating some things, right?
Correct. Yeah, we currently have the demo version of everything right now. So we've got probably more than what we're going to be utilizing in the office, but we were looking at just mainly civil and survey for our initial drivers.
Okay.
And
Well,
so
yeah, that's fine. I just want to get an idea of how much switching I need to do on the software as we go through it. So let's see, Jason Downs, how about you folks?
We got the Carlson just civil.
You got civil, okay.
Yeah.
And how about Jason Fisher?
Yeah, I'm running the Carlson Civil Suite.
Okay, so nobody's really running takeoff or the construction module, correct?
Right.
Oh,
Right.
all right. Well, that's going to actually be easier. So, all right. I'm going to go ahead and stop what we're doing and try to figure out what the heck's going on. I may have logged in under the wrong user ID when I started the meeting. I'll have to figure that out because, again, we've got this thing. We pay for it every month. And it's trying to tell me my free time is up in 2 minutes. So stick by your emails, take a 5 or 10 minute break, get yourself some coffee, make a phone call, and I'll send you guys new links for this meeting so you can come back in. All right.
Thank you.
thank you.
All right, see you in a bit. I'll keep an eye on that. It doesn't say. See, it doesn't tell me one way or the other which version I'm in. Let me see. Oh, here we go. Let me see. View my subscription. Yeah, yeah. Yeah, see, that's supposed to be edit the current plan. Your plan pro. Wow, it's still unclear as to what it shows. I think it's clear. Well, tell you what we'll do is as we go through, we'll see if in an hour, if it is going to run us out again. I gotta see what's going on with that, but I've switched to a different account, different username, so that may be all we needed to do. All right. Anyway, moving ahead, a little bit about here. You can see, some of my background, what I do. So I do this kind of work. I have my own consulting practice. I do this kind of work myself for clients as well as do the training for MSoft. So, I've run into these on real world projects and can help you out with some of that kind of stuff. But the key thing here is keep in mind this right here. You've got, and you all have my email address anyway from our communications. And at any point in the future on anything you're working on, if you got an issue or a question or something that you need help with, reach out to me, because that's part of what you get as an MSoft customer, is that you get access to us as tech support. And now you always have access to Carlson and their tech support, which is also free of charge. But a lot of times you'll get an answer back that is an answer coming from a programmer, or an answer coming from somebody that has never done this kind of work, or not never, but has a different sort of perspective on it. So, we certainly will function as your first line of defense in that regard to help you get, to make sure that you're using the software most effectively. So again, reach out when it's questions. We can help you do that. If it's something that's going to, and we can do individual remote control sessions, just like we're doing now with the training. So if you get stuck on a project, even if it's not something that we've gone over in class, we can certainly do that type of support for you, to get you back moving in the right direction. In fact, I'm working on a job right now with a guy that's a railroad surveyor, and he's having to lay in a private sidetrack and a backing switch to once he gets down at the bottom of the hill, he has to throw the switch and then back up his train cars into a loading dock at a factory. So, we're going through some pretty complex stuff, but that's part of that support. So don't hesitate to use those resources, after the fact, even if it's on, one of your projects. If it is something that says, I can do that kind of stuff, I'm going to spend about 4 hours on that for that guy. But I had another client up in Buffalo that, he needed to basically hand me a subdivision and say, I need you to finish this. I've got too much work. I can't get it done. We can do that as well. And, we'd have to do that at a consulting rate. We would, work that out through a proposal and negotiated rates and all that. So all of those things are available to you, as you go through this. And a couple of things in the book. if you see these particular little icons off to the side, that means in this case, that's an IntelliCAD only version of the software if you're running on top of IntelliCAD. If you see this one, an A, that means it's AutoCAD only. And there's usually an equivalent type of functionality in both platforms. So one just may be a command that you either don't need because IntelliCAD does it in a different fashion, or vice versa. So a little bit about, those kind of things. And then here's some other ideas to keep in mind. If you see a little light bulb, that's a good concept. If you see a little notepad, that means, hey, that's something to take note of because it's important. Okay. And then we talk about the software in general and how it works. And it's not all that crucial to understand any kind of nuances here, but this might let you know about what's going on, because we're really, what we're doing, we're not running a separate program that's that's geared toward surveying or construction, grading, or any of that kind of stuff on its own. It is basically running on, it's creating this CAD drawing, and it's relying on the CAD engine, whether that's IntelliCAD or AutoCAD, to create that drawing. So everything that you do in Carlson, you can do in just plain old CAD, but some of the things are a lot harder because Carlson sort of hides the complexity away from what it is we're trying to do. If we're trying to compute the volume between two defined terrain models, between two surfaces, well, we basically, as users of Carlson software, we hit a button and then we answer a question. This is, or what's their design surface? What's their existing surface? And it does all that work in the background. Well, you can do all that kind of stuff, like I said, as part of just plain old CAD as part of a drawing, but you'd have to set it down, plot it out, take a planimeter, measure out your contours, figure out the areas between your existing and proposed ground contours, So like I said, all of this stuff with the Carlson software is basically just giving some intelligence to these DWG files, these drawings, and hiding the basic CAD stuff behind it. So that's what that little discussion is about, and nothing, more, nothing deeper or earth shattering that you have to know about that, other than that's how it's working. It is at its heart still just a CAD drawing. Everything is still just a polyline, a piece of text, a point, something like that. Now, we're going to talk a little bit about how things are set up in terms of where your data goes. Now, we're not going to focus on this too terribly deeply. You get a lot of that in that fundamentals class, but these sets of pages here is going to talk about, how things get organized, some of the directory structure that's going on. And right here's the only thing that I really want to sort of point out here is that you have these three different methods right here of how to set up your folders, either using a project folder or using the drawing folder, which is the default after you install the software, or using a fixed folder. Most of us not even aware of this. We just are continuously using the drawing folder, and that's where things are going to look. Okay, but we'll see where we can change that if we need. What's good about this project folder, and you can see here, it lets us create a project, and then it builds a list of folders and subfolders in there that we define up front. We'll say, these are the subfolders I want in every project I do. It takes care of creating all that for us. And then these locations, you can see like a DWG file. And there's other places we might see, like points and center lines, whatever it else is, that other files, we can say, I want it to go in this folder. I want that kind to go in that other folder. And that all it's doing is just creating default locations for the software to find and to save these files in, but we can navigate away from them anytime. If you're all using this drawing folder method, and that means it's going to, by default, always look in the same folder that your drawing is in for your data. And that's perfectly fine. In fact, I do most of my stuff that way, personally. So that'll be a little bit about that. And then over here's an example of where you can assign, say this one right here, number 8 is a .cl. That's a centerline file. And we're telling it, I want that to go into this folder that I created called, under project, it's called data. And then under data, it's called alignments and profiles. That's where I want it to go. I want my CRD files, my coordinate files, to go in under project, under data, and then in another folder called points. So you can assign however many of these files that you want to specific folders that you've created back here as part of that project folder setup. Okay, and we'll show that real quickly when we get to it. We're not going to dwell on it there. I'll let you go through this stuff on your own. The general versus modular menus. It's basically file, edit, view, draw, inquiry, settings, and points. Those are our general menus, and they're called general because every Carlson module has those same menus with the same commands in them. It doesn't matter if you're running civil, if you're running survey, if you're running CADNet, if you're running GIS, hydro, they all have file through points, and those are our general menus. The modular menus are the ones that take off after points, and they become the ones that a specific module has. So if you're running survey, you'll have after points, you'll see a menu called survey in COGO, centerline. Civil will have 3D data, surface, SiteNet, etc. And some of these have some overlap, like you're going to see surface in both survey and civil and hydrology, but they have slightly different commands possibly in them. Or some will have a lot more, functionality in there, like the profile menu on the civil module. There's a full profiles menu here, whereas in survey, you don't have that, but you do have a profile section on the centerline menu. Okay, so we'll show you some of those kind of things as well. So that just sort of shows you what those are. Nothing to really get worked up about or to write home about. Now, settings, we need to go over, and again, we're going to do that to sort of dig into several settings that are going to make some sense for us. And then we're going to also talk a little bit about building surfaces, not so much about these points and point groups. I'm going to leave a lot of that stuff to your own review. It's there for you as part of that upfront stuff through that first putting it all together type exercise. Okay, but as we need to, we'll use those same commands and concepts as we go through our examples with our data. Okay, so with that being said, let's jump over to load up our Carlson software. And I'm going to run the IntelliCAD. Well, first of all, which versions are you guys running? IntelliCAD or AutoCAD?
We'll probably be going with the IntelliCAD just because of it doesn't require the same amount of horsepower.
Yeah, and it also doesn't require the same amount of dollars.
Yeah, true that. Good call.
IntelliCAD,
Did you say AutoCAD?
well, IntelliCAD,
Oh, IntelliCAD, okay.
Yeah, I'm using AutoCAD.
And Jason Fisher, you are in AutoCAD?
Yep.
Okay. So when we see some of the dialogues, you might see some slight difference there, but let me know if it's something critical. I've got both versions, but I'm going to be probably limiting what we're looking at to the IntelliCAD version, just to match these other guys a little more closely. So, but again, it's going to be the same type of functionality. So software is going to come up. You're going to get our little start page that's going to have some functionality for us here to create new or open recent files or open files from a folder. You've got these links on the side here, and don't neglect to look at these if you need, like, to go to Carlson support or go to the knowledge base. This can take you straight there. And also over on these right-hand side are some little, news that Carlson has published, things that they've done in the news. There's a little tip of the day that you can scroll through, vice versa. And your recent documents, if you want to keep one up all the time, you can, hit the little push pin so that it's pinned and it will stay there and won't time out and go off the list. All right. So nothing more than a typical start page, and the AutoCAD version has, the AutoCAD start page that this is sort of modeled after. So AutoCAD's is really was there first. There's one here called Drawings Map that if you have a whole bunch of projects and they're all done with a particular coordinate location, that's like state plane coordinates, and it knows how to find that location on, say, like a Google map or something, then you can actually do that. It will go to an interface like you would see, somewhere on the internet. To you've seen mapping interfaces. You could zoom in and it will show you where all of those projects or drawing files are centered in, whatever coordinate system that you may have used. It knows where to find it. I've never seen anybody really get a lot of functionality out of that because they know where their files are, but otherwise it could be handy. All right, so let's go ahead and just start a new drawing. And I'm going to take some defaults here. I'm going to say use a template drawing, use a DWG type. I'll hit next. I'm going to select a template. I'll just select the Carlson NCS Survey Civil, and it really doesn't matter what you're going to use. That's the Carlson National CAD Standards Survey Civil. That's going to control a list of layers and colors and line types and all that kind of stuff that was pre-built in the template. It doesn't matter at all. You can use that or not. And I'm going to say finish. And it's going to go next to the next step of the new drawing wizard. And this is something that you can turn off right down here in the lower left. You can see that you can turn that on and off If you don't want to go through this wizard. Now, I like to have it on because it forces you into certain discipline of setting things up. Now, you would set up a particular scale that you know, maybe you're trying to model a bunch of drawings that you get from another company, and maybe they're published primarily at, say, you know, 1 inch equals 20 feet. Then you might want to say, put that in to sort of match. Now, when you do that, all that you're doing here is saying, I expect to have, if I were to plot this work as a plotted drawing, and that's not what we're going to be doing as part of doing machine control, but if we did, then it's going to control the size of the text and the symbols that we use as if we're going to be drawing those final drawings at that final scale. Okay, so 1 inch equals 20 feet. And then you're going to see, and this is a keyword right here, symbol plot size or text plot size. You will also see another word used sometimes in some other dialogues that says symbol scalar size or plot scalar size or symbol or text scalar size. So you'll see those two words, plot size or scalar size. And when you see that, all you need to remember is, hey, that's plotted inches. And so you don't have to try to figure out, you know, what is 1/10 of an inch at 20 scale? Well, it's 2 feet. All right. 8/100ths of an inch is 1.6 feet. So if I wanted to do this, say at, you know, it say something at 60 feet, notice it recomputes. Now, these are the numbers over here that it sends to AutoCAD or IntelliCAD. Whereas this number, and it's going to stay in our dialog boxes as to whatever we've used it last. So they're going to pretty much be things you never have to set more than a couple times to establish a pattern. So it's going to automatically change for us and send the right numbers into AutoCAD because AutoCAD doesn't know that we want it at 1/10 of an inch. It needs this. It needs to figure out how many ground units it's going to make a symbol or a piece of text. All right, so that's how that number gets done and gets applied. These pretty much stay the same. That gets recomputed. And then if we're using a particular projected coordinate system like state plane, you know, you could set those up to be, you know, to match whatever location you're using. And then that will help when you go to load in aerial images or anything like that, that you download from the internet or from Google Maps or things like that. If it's defined in state plane coordinates, it knows how to do it. You don't have to worry about bringing an image in and scaling it and rotating it and moving it into position. Project name, job number, and location, those are just things you can type in and they will fill out certain lines on reports, just like header lines, you know, titles and subtitles, nothing more than that. Now, here's the next thing that's going to happen is why I like to use this wizard instead of skipping it the next time. I want to say next, and it's going to complain that, hey, you didn't put the drawing name in. Well, right up here, that's the first thing I should have done, but I immediately started talking about scaling. So it forces me to make sure I know what to call it and where to put it. So I'm going to say set. I'm going to click that set button. And I'm going to go and find wherever it is that I'm working. Now I have some things set up under my Carlson projects. And the folders that I have in that folder are over here on the side window called subfolders. And I see one called 2022-08-25 3D machine control class. I'll double click that. And then I've got some other subfolders in there as well, but I'll leave this in that top level folder. And I'll just call this class example 1. All right, so now I've defined my drawing and I can say next. And it's going to move that file there, give it a name. Notice up here at the top left where my drawing file tab now has a name, and goes to the next part of my wizard. I have a data path and a coordinate file. And that data path is pointed to that same folder, and the coordinate file that it is going to suggest, because I'm doing a new file, is going to be a CRD file of the same name, and it's going to put it in that same data location. Now, notice they each have set buttons, so you can change those. And at any time, you change the data path. So let's say you wanted to put the data in a completely different folder. You could do that. And all this is doing is giving the software a default location to start looking first. You can always navigate away from all of these things, okay? So, new coordinate file by the same name. You're not required to have the coordinate file match the name of the drawing. In fact, we quite often don't. If we need to keep one coordinate file running with many drawings, we can do that as well. Whether it's a new coordinate file or an existing file, whether we import points as part of this wizard or not. So we're just going to say it's a new file. We'll take the name, no importing. So it's basically just going to be empty, and we'll say next, and it's going to finish up and come back now to our command prompt so that it's ready to go. Now, let's talk about the interface a little bit. We've got, or I've got showing here a bunch of toolbars. Both horizontally, I've got 3 rows across the top. I've got vertically a row on the, a column on the left. I've got a column on the right, which actually has 2 toolbars in it. One's underneath the other one. I've also got slightly collapsed over here, this palette, which also has a lot of commands and toolbars if you choose to use those. And if you're really, really bored and want to get into some near programming stuff, you can go look up how to modify this stuff and do your own customized palettes. I'm not that bored myself. So now, one thing you don't see me using is the ribbon interface. And the only reason for that is just my preference, because if I want to, and I'm pointing up here in this empty gray spot, and if I say switch to ribbon, now I've got these ribbons. And if I switch different categories here, it's going to switch to the different ribbons. If I switch to survey, I now have, you know, like field to finish, data collector, deed descriptions. If I go back to draft, this is where I can start drawing all of my particular functions. If that is, you know, here's say, for instance, on the, you know, things from the edit menu, if that is the way that you like to use and learn the software, that's perfectly well and good, because you know, it tends to be a workflow based context. So file has file things in it, setup has setup things in it, etc., etc. Area layout, centerline annotation, etc. Okay, but I tend to use instead these menus. These are the Carlson menus. They're always going to be available. And then the toolbars give me my productivity, my functionality, and all that. But that's entirely up to you. I'm going to right click now and say switch to menu bar so that that ribbon interface goes away. And here's the other reason, the real reason why don't use it is because it takes up even more of my screen. Okay, so I want to keep maximum functionality in my screen. Now, a couple of other things that I do have, you see over here on the left, I have my properties panel because I do that all the time. When I go to select items in my drawing, I go to my properties. You don't have to have it docked. You can float it. You can put it on a different monitor, or you can just load it up every time you want to use it. Okay, so that's where that's going to be. Now, a couple of things about toolbars and how they get turned on and off is I'm going to again go up here and right click and choose from that context menu, show toolbar, and you see I've got Carlson toolbars, Carlson DGN toolbars, which means it's going to work with MicroStation DGN files. I've got CG survey toolbars, iCAD toolbars. Those are my IntelliCAD toolbars and my IntelliCAD DGN toolbars. Okay, so these are different categories. These are the ones I'm going to be more concerned with are these, the ones under my Carlson. And you can see I've got, for instance, a draw toolbar there. And that happens to be this one on my left-hand side of my screen vertically. And that's a draw line, draw 2D, polyline, 3D, polyline, etc. Because these have the tools that I find very handy. If I look under IntelliCAD, notice it also has a draw menu. I'll turn it on and it's right now floating. If I put it over here vertically, oops, let me get it to, there it is. Notice it's got some similar things like there's draw line, array, and infinite line. This one is 2D line. That's a Carlson draw line. This is an IntelliCAD draw line. And the big difference between these two sets of commands is that when you draw a polyline or a line or a 3D polyline, etc., anything that you do using a Carlson command, for instance, if I go to, this is my standard CAD polyline. I draw that, look at my prompt. It says start a polyline. So I can either click a spot or I could type a coordinate value. And now you see I've got things like arc and distance and follow and half width and width, so certain options. But it says next point. When I either have to click a spot on the screen or type a coordinate value, and I'm going to say just at 50, 50 meaning, I type this down here, meaning go 50 units in the X and 50 units in the Y to the next location. So that's, that part there. So that's, 50 over and 50 up from where I last was, and click and click. Now, watch this difference. If I go to my Carlson draw 2D polyline, and I'm just going to say, okay, we'll go over that some other time. I've got some of those same functionalities down there, continue, extend, follow, some options. But notice right here, and this is what I was getting toward, the big difference between a Carlson version of a command and the plain old CAD version is this. It will say pick a point or point numbers. So I can still do just like I've been doing, and even say at 50, 50 for that one. So I can do the very same functionalities, but when it says pick a point or point numbers, those are my survey points, my Carlson points, part of my coordinate files. I can use point numbers in addition to just showing it things on the screen or typing a coordinate. What do I have when I'm done? If I select that and I look at my properties, I see it as a polyline. If I select this one and look in my properties, I see it's a polyline. Just happens to be on a different layer and a different color, right? but the net result is the same. So if you want to draw something with the IntelliCAD or AutoCAD tools, you're perfectly welcome and free to do that. But the Carlson versions of these same commands are going to give you a bit more functionality. In particular, they're going to be with points, with Carlson points is going to give you that functionality. So that's why I don't really ever even use these IntelliCAD draw commands. I just use them from here, and I've gotten so used to them that I prefer those. In fact, there's times when I'm not even using any coordinates at all, and I go to do it and I forget that they're not there, and I try to use point numbers for certain things if I'm not even using them. So, but that's the biggest difference right there. And the key thing that these toolbars are going to give you, or the ribbon, or anything that you want to do, is a bit more productivity. It's going to give you some quicker ways to get to things, such as on this menu, I'm hover the mouse up here over that those dots. See, it says polyline. So that's my polyline toolbar. And here's a command, for instance, that is very common: remove polyline vertex. Okay. Now, that is, in fact, if you'll draw yourself what's going on here? Let me see. Yeah, if you'll draw that's what it was. Okay, so if we've got a polyline like this, now we know with new modern CAD software, we get these grips. And if I want to say remove this vertex, all I have to do is hover the mouse in the grip and a little menu comes up and I can remove a vertex, no problem. But what happens in situations like this, where you've got a bunch of them, and if you wanted to remove, say this one, but not that one, you got to go in here and hover the mouse, remove vertex, hover the mouse, remove vertex, hover the mouse, remove vertex, or even worse, the old p-edit command, the polyline edit command. And I have to type E to edit the vertices. Let me see here, sorry, p-edit. Select the polyline. There we go. Now edit vertices. And if I wanted to remove one of those, I have to go next, 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 next. And let's say I want to move the next three ones. Well, I'm going to say straighten. Then I'm moving it next, 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 and then G to go, and then X to exit, and then exit again. All right. Bit of a wonky command, but Autodesk programmers, when they created the p-edit command, decided they wanted to try to put everything in a single command. Carlson takes the opposite approach. It gives you a command to remove polyline vertices. Okay, so they also then give you another command to straighten, or to add vertices, or to do all kinds of individual things, but they are typically here under this polyline utilities menu, which is under edit. There's your p-edit. That's what we were just doing. But right in here is where you can do things like add a polyline vertex, or you can remove a polyline vertex or segment. So that's the command we want, but notice how deeply buried it is. It's under edit. So you click edit. You come down to the bottom, you click polyline utilities. You go one to the right, you come down and click remove polyline. You go to the right, you come down and choose remove polyline vertex. Well, that's click, 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 and trying to keep track of that. Or you can simply know where it is on the toolbar. It's right here. I click this, and now I can just freely come in here and click, whichever one I'm nearest. I don't have to snap to it. It's just whichever one I'm closest to is the one it's going to get rid of. Okay. And then be done. So to get back to where we started on this particular discussion, this toolbar, this Polylines toolbar, which has this extend by distance, boundary polyline, join nearest, reduce polyline, so and densify or add additional vertices. And here's one that there's my remove polyline vertex. That's the one that I just showed you that was buried really deep. Here's the opposite of that, or the corollary there is to remove a polyline segment. You can also add a polyline vertex, but notice the icon that is showing. Okay. If you look on the menu, there's my remove polyline vertex. It's that exact same icon. So what this is useful to remember. Look at this menu, this set of menus that are showing here. And in particular, look right in here. Oops, let me see, look right in here. You see that reverse polyline, reduce, densify, smooth, and then down here, close or change width. These other ones in the middle, like join two polylines, merging closed polylines, or poly edit, those don't have these little icons, but the ones like reverse polyline, reduce, densify, smooth, close, and change width, they do have icons. And what that is telling you is that when you see an icon for a command in the left part of the menu, that lets you know that it lives somewhere on some toolbar. Doesn't tell you which, and you'll have to sometimes, sort of search it out by logic, meaning these are polyline type things. So I'm going to probably want to look at, when I start to explore these toolbars, the polylines toolbar. But we've also got things like right here is called join nearest. And that also works on polylines. And up here, you see that same icon for join nearest. So it's also on the polylines toolbar, but it's not actually in this same menu set. But I know because it has an icon, it's somewhere, and I'll try to figure that out. Same thing with viewing all of these layer type things. I've got a layers toolbar. I've got a Carlson layers toolbar, and I've got an IntelliCAD layers toolbar. The Carlson one also has this nice little thing called erase by layer. That's actually part of this menu. It's not part of the view layer group, but it's very convenient to be there, and it's a very, very useful tool. So bottom line to all that is get familiar with those and what they do, and arrange them however you find best suited for your own use. There's no right or wrong. If you like the ribbons, that's fine. But for uniformity's sake, we're going to take everything, learn everything from the menus. And as we get more and more familiar with those, and I show you which toolbar they're on, we're going to use a couple of the toolbars. And in particular, we're going to use these SiteNet tools when we start to talk about some of the takeoff stuff. And there are a couple of toolbars that we'll bring out when that time comes to take a little closer look at that, because those two particular toolbars had the icons across the toolbars left to right are the same as the workflow order that you would do in a particular job to set those up. Okay. So that's that part. Another place you can set those toolbars is on the settings menu with the toolbar setup. The toolbar manager, for instance, lets you load and save toolbar files, which is basically a configuration of which toolbars you have out, not a list of commands on each toolbar. It's which toolbars. So that lets you do that. But if you look under toolbar setup, you'll get this. And you notice here's some of the toolbars, and you see the ones that I have out are the ones I have checked. Do not neglect this right here, because this switches context as to which sets of toolbars you're looking at. So if I'm looking at Carlson, I've got the Carlson menus. That's this one right up here that lets me switch between survey, civil, hydro, GIS, etc. I scroll on down a little bit here and I see the next one is draw. So there's my Carlson draw tools on the left. Entity properties. Those are these things like which color, line weight, line type. Right now they're all set to by layer. Grading tools. Now those are these commands right in here that set certain drawing elements to either particular elevations or to drape things on surfaces, etc. I've got inquiry, and really the only thing I use this thing for more than anything else is this one right here, this little standard distance command. And it's just, you know, I could type DIST and hit enter and not have to use that toolbar, but it's there. I like it. It's the way I work with it. Layers. And again, I talked about the Carlson layers toolbar. There's also an IntelliCAD or AutoCAD layers toolbar, whichever one you're familiar with and comfortable with is perfectly fine. But these correspond to some of the commands I like, and I like that erase by layer to be on there as well. And then polylines, we talked about that. I find that very, very useful. And you may find as you go along and use Carlson software more and more, that you may notice that Carlson really, really likes polylines. There are some commands that won't work on lines. They will require polylines. And it's so much functionality in the Carlson world is derived from these polylines that I cannot tell you the last time I drew a line. So even if I'm just drawing a single segment, I'll still draw it as a polyline. Everything that I've done in the last 15 years in a CAD system has been with a polyline. Now I've got a surveyor client friend of mine who he's used Carlson survey for, I don't know, 30 years. He very rarely draws polylines. He draws almost all lines, and that's just his preference. Well, that's well and good until, you know, it's time to go stitch things together. Then he has to stop and do a join nearest and worry about elevations, whereas, you know, your approach to it might be different. It's not going to be wrong. It's just going to be a different approach based on whatever you may need. So just be aware of that. And then I've got standard, which is this up here, new, open, save, print, etc. And surface, which is the second one down horizontally on the left, from the top all the way to the left. And it's got things on there. And the ones that I really use the most is this leftmost one, which means triangulate and contour. Go and run the command to build a surface. And then I use 2 over here, almost exclusively without even bothering with some of these others. I do use them, but these are one I use most often. One which that looks like that 3-colored cube. In fact, that's the name of the command, cube. That lets me view things in my drawing that I select in a special 3D viewer. The one that is 2 icons to the right of that, which looks like a little diamond, is a 3D surface viewer, and it's going to ask me to select a surface file, which would be an external file, and it will load that into the drawing as if I had drawn the triangles out into my drawing as solid faces, and then selected those faces and viewed them with my 3D viewer. So that keeps me from having to clutter up my drawing by drawing a bunch of triangles. It's in the definition of the surface file. It reads that definition, puts it in the viewer. And that viewer, as you're going to learn as we get through this stuff, is really the same viewer. I can go into this one, load up a bunch of stuff from my drawing, and then go over to a tab in the controls and load a drawing or load a surface file up inside of that viewer that looks at it in addition to those selected items. I can also load the surface first and then go to that other set of controls and load up a bunch of things I pick out of the drawing. Anyway, it's just a quick way to get to that. And I need a quick way to get to that because when I am building a surface, I'm going to build it, I'm going to look at it, and I'm going to evaluate it, and I may spot something visually with my eyes that I see, hey, there's a problem here, this is wrong. So I'll exit, I'll come back to my drawing, I'll fix what's wrong, I'll build it again, view it, exit, build it, view it. So it's back and forth until I'm satisfied with that surface. So I don't want to have to go to my view, 3D view, surface file viewer. I just remember which button. It's a lot easier to go click or click instead of trying to navigate into these pull right menus. Okay. So those are the ones that I find that I use. That was the surface. And then finally, these transparent points and selection commands. That's over here at the bottom most vertical one that are just some temporary snap stuff. And then on the IntelliCAD, I've got the entity snaps. That's these right here. And I don't ever really use them from the toolbar. I put them there as part of a class. So I know a lot of people like to use them. I like to use my shift right click mouse button combination. I hold the shift key and right click the mouse, and that lets me pick from a pop-up menu of these as I need them. But anyway, they're there. And I see that I've got the modify tools, and that's this one vertically on the far right. And those are the standard CAD tools like move, copy, there's offset, there's scale, there's rotate, mirror, break, fillet, explode. So those are all things that I use quite a lot. And I don't need any particular Carlson functionality out of them. I could find some. If I needed some, I could do those. In fact, there are certain things that I can't do. Like I can't offset a 3D polyline with this command. I have to go to the um, 3D polyline utilities, offset a 3D polyline, because Carlson will let you do it. AutoCAD or IntelliCAD won't let you do it. But Carlson lets you do it because it knows what you really mean. You're not really, quote, offsetting that 3D polyline. You're offsetting the projection of it as you look on it straight down. So you want it to go over a certain distance away, but in the vertical world, you want it to maybe be the same as the original. Like if you're building that as part of the top of a wall, you want to kick it over a foot and keep the elevations exactly the same. So it does all that stuff behind the scenes. It creates a 2D version of that 3D line, offsets it a foot, and then it goes and reads that line and figures out what the elevation of those offset vertices need to be, for instance. Okay, so there are certain things that you can't do with these, but these are the standard modified tools, and that's where I use, and those are the ones I find most useful. Okay. Now let me show you one other thing that I find really, really useful. And it's with the IntelliCAD version as opposed to AutoCAD version. Right here, there's a command. It's called layer control. It's on my layers toolbar menu. It's the icon that is immediately left of the little layer pull down, which is left of the, the color, line style, line weight properties. This one here is called the layer control. If I click it, and in AutoCAD, if you click it, it's going to bring this up for you. This list of layers where you can set the color, the line style, you can freeze and thaw. And if you're in paper space, you can have a whole different viewport controls as well. But in IntelliCAD version, notice up here in the top of this brown stripe, mine's brown, whatever color yours may be, it says Explorer layers. That is a command called the IntelliCAD Explorer. And right now it's looking at layers. Well, look here on the left-hand side. I can look at layers. I can look at layer states. I don't have any line types. These are all my defined line types in this drawing. I've got text styles, any coordinate systems, any saved views, layouts. Those are these paper space tabs. Any blocks. I don't have any blocks in this drawing yet, but if I did, I'd see them. Dimension, styles, groups, materials, and external references, which will include PDFs, other DWG files, any type of, let's see if I add, say I can use a drawing file, an EGN file, PDF, point clouds, image files, anything that I can bring in. Now, AutoCAD makes you, for image files, for instance, you have to run the image attach. For PDF, you have to PDF attach. For a drawing file, DWG file, you use the XREF command. Now, you still have, for instance, if I type XREF here, see, I still have this attach, and I could bring in, let's say there's cross sections TR77. Okay, so there's still that file is in my XREF manager. So if I can still do that, so there's nothing wrong with that. It's the same command in AutoCAD, but I've learned to do things with this. There you can see there's that cross sections TR77. So I've learned to do things from this because I remember that I can switch in and out of this and control so many different things with one command. Okay. So, and there's nothing wrong with doing it with the XREF as opposed to doing it with this one, but just keep in mind as you look at these things, look around and look at things like the title that you'll see in a title block, because it may give you a clue as to what's available. Now, here's something else that you might have. I'm going to go to the file menu, and I'm going to scroll down here and just find a another file called Working Geometry. This is my little railroad project. And All right, so I now have two files open, this one and this one. Let's say there's something in this file that I want, maybe a dimension style or a line type or something that I like that's in this file, but I don't have it in my file. I don't have it defined in my file. Well, if I run that same command that we think of as layer control, this is how you just control your layers. Okay. In fact, on the view menu, it says layer control, but it's going to bring this explorer up. Now we see our layers, layer names, colors, line type assignments. This is our file, but because I have two files open now, here's my other file. Well, I've got these layers in that file. I've got, let's see, here's railroad proposed. It's cyan and it's going to use a railroad line type. So all I have to do with that is select it here and drag it and drop it onto the same category in the other file. And it can go either direction. I may look at, say, blocks. Here are these. Let's say I needed 2 blocks out of that file, just drag them and drop them here. Okay. Any external reference files, you could do it like that if you wanted. That didn't make any sense for that one, but in this case, you get the idea. Text styles. Here's one called profile title that I don't see. There's nothing here, but here I'll just drag it and drop it. Now, oh, same thing, line types. Let's see, we started that one. Here was our fence. I'll put that over there. Now, and I can close that off. But if I go back to just this drawing, in fact, I'll go ahead and close that. So now I've just got the one open. I will look at that. I'll look at my layers. Remember, I had that RR proposed for railroad proposed, right there it is. And the line style, let me find the, well, it's a railroad line style. But what did we copy over? We copied over that fence. Got quite a few. There it is. Here's my fence. Okay, so here's my line types. Text styles, there's that profile title. I also have these blocks that did not used to be in this file. Now they are defined as part of this file. And so very, very powerful and useful command. Don't lose sight of the fact that when you run the command up here thinking it's layer control, or even if you run it from view layer control, that's all you can do is set the layers. But you can also set your text styles, etc. In AutoCAD, you can't do it there. You have to run the styles command, which you can also still do here in the style command. And so there's now profile title, and got a font that I'm going to use, etc., etc. Okay. Neither's right, wrong, or indifferent. It's just that there's a lot of stuff that IntelliCAD can give you. And the same thing's true for AutoCAD. Just dive deep when you need to try to figure those things out. Okay. So now it has been more than an hour. So it looks like switching the login took care of that issue. So we're in good shape with that. All right. All right, so the next thing to remember or to look at, is there anything about any of this that might be any questions that anybody has. Let me sorry, let me try to get back to my previous view here. So we have- oh, there we go. Oh, I say sorry about that. That is this. Tangent. There we go. Now, any questions about the interface, toolbars, what might be good, what might be bad? Everybody good with that? Looks good. Okay. So let's talk next about some settings that are going to be useful for us. First of all, if you are, and I think all of you guys said you're using Civil. So if I'm in Civil, I'm here. I presume you've got Civil Suite. So you'll also have Survey, where you'll have these survey commands as well as Civil commands. So using Civil, the traditional command set that is part of quote takeoff, which is what we typically associate with 3D machine control. For whatever reason, it doesn't have to be done that way, but I guess it's because a lot of contractors would purchase the Carlson takeoff application. But you really don't need it as a separate application, but it does have a couple of things that are that sort of make the process a little bit more streamlined. And I'm going to show you one of those particular things, not to try to get you to go out and buy takeoff or the modular equivalent to the takeoff product. Takeoff itself is a standalone product that only has as much AutoCAD in it as it needs to run. And it's doesn't run on top of AutoCAD or IntelliCAD. It runs on a subset of AutoCAD. But it has a corollary in the modular world, and that is the construction module. So if I go to my Carlson menus to the construction menu, it gives me these, and notice I've got this takeoff menu here. Roads, survey. So that gives me some civil tools, that gives me some survey tools. And I've got annotate, and I've got some display controls over what I'm doing here. And I've got these elevate tools. Now these tools are some that are found on Civil's 3D data menu. Surface, so these are also found on Survey and Civil in the surface menu there. But it's this takeoff workflow that this is providing. One of which is it also gives you a project checklist that tells you that you've got these 5 things that you typically do in a workflow. You define your targets, you set a boundary, you make existing, you make design, and then you calculate volumes, none of which have been done. As you do those things, these will change and show you that you have done them. So it's just sort of something there. But the main difference between takeoff, now when I say takeoff, I'm going to refer to this construction module or the takeoff standalone, like takeoff R12 product that I was talking about. The main difference in the approach to building models is this. In takeoff, whether we're doing it here modularly or using the OEM product, when we build surfaces, it is created to sort of hide the complexity of all of that to the user. Notice it is, you'll see things like set the layer for existing, set layer for design, and then layer for other, because that's all that you ever have is existing or design. Everything else is other. Okay, so, and then you'll see make existing ground, make design. And then you calculate some volume. So it happens to be, one of the items here is to define the layer surface material subgrade. And when I do that, notice here's existing, here's design, here's other. So if I have certain things here that are existing, well, these, or maybe they're design. So I'm going to move them there. It doesn't do anything to the layers. It just puts them in that different category. And I'm going to come down here. I've got some V layers. I'm going to move those to existing. And then I would save that list. So now I've got things on these layers are existing. Things on these layers are design. Everything else is other. So if I then save and exit, and then I can control my, I'm not going to say that. I would then control my visibility of those groups of layers by simply saying show or hide existing, show or hide design, show or hide other. And there you'll see that down here, for instance, on the display, see the display existing, drawing, the things in the drawing that we defined as existing, the contours and the surface that are derived from those. Then the same thing with drawing, or I'm sorry, same thing with design. So there's existing, design, and other. So everything is geared toward that, and it's geared toward assigning layer names, and things that are drawn on certain layers then become the definition of those items. Now, what happens if you have, say, a building outline that is on a layer called site, just as an example. And then maybe you've got a bunch of parking lot stripes, the parking spaces, the stripes in the parking lot. And they're also on that layer called stripe, or layer called site. So if you then say in my definition for design, I've got site because it has my buildings on it, but it also has the parking lot stripes. Well, those parking lot stripes don't need to be part of my design. They would be, in that instance, on the wrong layer. So part of this thing is when you do things through the takeoff way is that everything needs to be on the proper layers. And you might spend some time changing some layers and defining where things go. And that part's okay. You can do that. But in the civil approach, if we're going to do it through the, say, civil menu, I'll switch to that now, is we're going to do things here more manually, and we're going to go out and select items that become parts of the surfaces, as opposed to the layers that hold the items that become parts of the surfaces. So in this case, I can then say, just select the buildings and ignore the parking space stripes, even though they're on the same layer, but that lets me do that by being selective as to what I choose to go into those makeups. So in civil, I've got all of this fine granularity over top of all of the surface building, but in takeoff, it simplifies me. It simplifies my task as to, I don't have to worry about going and selecting everything. I just tell it what layer it's on. Now, one other option that it does in takeoff that we would have to, when we look at things is, again, remember, it's only concerned with two surfaces, existing and design. But in civil, we can have 37, 262, however many surfaces that we need. We just give them different names. In the takeoff approach, it's going to name your surfaces for you. And it's going to do it with a series of suffixes on the file name for the surface. And the file name for the surface is going to be the same name as the DWG file. Now, what those are here. I'm going to go to settings, Carlson configure, takeoff SiteNet settings, and it's these guys right here that are the suffixes that get used when it builds the original ground. That's my existing ground, and over here is my designed surface. So those are the two conditions, but it's going to have this -OG for original ground. That means before any adjustments. -ZE, that is after you take out any subgrade zones like topsoil strippings or I'm sorry, subgrades. And then after zones in topsoil. So if you do topsoil stripping that you don't want to include in the original volumes. So it creates 3 existing surfaces and 3 design surfaces. So no adjustment. So that's just your base design. Here's ZN. So that means after you've accounted for your subgrade zones, so it can take that subgrade, it can take a top level design down to the subgrade, and that can be done in different thicknesses in different places. And then it's got a final FN that is after it's done the zones and any topsoil replacements. So the amount of topsoil that goes back on something to build it up to the final contour, if you don't want that included in your materials, then you would use, one of these separate surfaces. Okay, and it keeps track of all that for you. And then of course there's one other thing here for over excavation. All right. So that's the difference, is that the takeoff approach again is a existing design, and that's it. What's their existing, what's the design, but it accounts for subgrades and topsoils, etc. The civil approach is you collect everything and you name those surfaces. So if you want to make the subgrade If you want to subtract out the subgrade of that final design, then you need to figure out what creates the subgrade or how much to lower the design surface within a certain area. Okay, or raise it or whatever the case may be that you're looking for, and then give that new surface a different name. So you have a lot more housekeeping to do in the civil method versus in the takeoff method that has a little bit more simplicity of organization, and but it has a little bit more sophistication in materials and subgrade handling. Now, here's the part that is, after you get all of that sort of fire hose spray to try to digest. Here's the good news is under civil, and I'll switch back to my civil menus. You see that 3D data. It has a menu called SiteNet. Notice it has some of those same commands that Takeoff had. Define the layer for surface materials and subgrades. You set your layer targets for existing, design, and others. You've got display existing, display design, display others. You've got this make existing ground, make design surface, and then you've got this calculate total volumes. So, and material quantities and all of that. So it's got basically that same workflow that construction has, just not quite the level of detail that construction has. And one of which will be, we look at these settings, we go back to settings, Carlson configure, Takeoff / SiteNet settings. That's why they're combined there, because that is whether you use the Takeoff method or the SiteNet method. Here's some of those settings, and it's still going to use that same set of surface naming suffixes. And up here is things that you're going to want it to do or not when you compute surfaces. And down here is a very, very nice approach to managing some of your data with that Takeoff method. And it's going to show you things that are existing in whatever color you choose, green, for instance. What are design entities? They're going to be blue. And what are other, in other words, the things that are not defined as existing in design, it's going to make them gray. And it will actually show, you can have it display in the model with those colors. And all it's really doing is it's going out and selecting everything on those layers and changing their colors from by layer and making them green. Same thing for design. It goes out on the list of layers that you set are designed, selects everything and changes its properties for its color to be, instead of by layer, it now makes it specifically whatever color you've assigned it here, in our case, blue. But here's the really nice thing that Takeoff does, and the setting, the control for it is here, and you notice it says Takeoff entities color assignments. So you get this display business even with SiteNet, but this doesn't say anything about SiteNet here. But it's this one right here that if you assign colors by elevation, meaning if it does not have an elevation, make it red. Even if it's on this layer for existing or this layer for design. And you're saying if it's on these layers for those two particular things, they have to have elevation to be able to build a surface. So this is a way of leaving it, whatever color you set, in this case red, leave it red until it has an elevation. And once it does, it then adopts the color assigned up here for whichever category it belongs to. Okay. So that is available in Takeoff or the construction module, that red color. It won't work in SiteNet in civil only. You have to sort of keep track of it and know whether or not something has an elevation. Now, it will show you the green and the blue and the gray. It just won't do this color updating. Okay, so that's okay. It's not necessarily a problem until you get, let's say, you're trying to model the existing ground and you've got a PDF file that's got like, you know, several thousand contour lines, and you can't remember if you've given them an elevation or not. You have to stop and look at it in 3D or select it and look at its properties and see if you've elevated those lines or not. Okay. So, and if you do a whole lot of that kind of work, that is something that might become beneficial to have, that construction module. But if you're not, or if you don't do sites that are so large that you can't readily keep track of whether you've given them elevation or not, then there's no need for that module. You can certainly get by with just the civil. Okay. So with that said, we're going to we'll come back and take a look at what those settings should be here in a minute. But it's now 11:15. Go ahead and let's take a 10-minute break. Let's come back at 11:25. So we'll take our 10-minute break here. We had one a little earlier. We had to switch sessions, but this will give you a chance to have a little bit more than just a 5-minute break. And so take 10, we'll come back at 11:25. We'll go over settings until lunchtime, and then we'll get into some of the example exercises. Okay. Any questions to this at this point? I know it's, and I apologize, it's really dry material right now, but it's important to understand those distinctions. But any questions for anybody?
Looking good.
Okie doke. So if you'll pop back at about 11:25, we will get back. Just when you get down, just give me a thumbs up or unmute and say, hey, you're back or whatever. And I'm going to then pause that. You'll see when I'm back, because that'll come back on. And at some point, let's see, I gotta pause the recording. Okay, I'm back whenever you guys are. We'll take the next step.
I'm back.
All right. The two Jasons are back. Alex is back. Looks like we're all back. Okay. Now, what we want to look at next are some quick settings, and we'll finish this part up, and I think it's important that we know what these settings are going to do for us in our drawing, because they can have some effects in different ways, how it works. Is first of all, Alex, you're working with the new version, which I guess 2022. Are either of the two Jasons using 2022?
I got 2022.
I got 2020.
Okay. And if you've kept up and have downloaded the latest release, the latest patch, the update, there is something that got set incorrectly, and we didn't notice it until I had a client that had a problem. He's a surveyor, and so and I know you guys do some survey stuff, and it has to do with our, it has to do with the annotation issues. So it may or may not affect what you're doing directly to generate surfaces, but it could if you're doing layouts based on the calculated annotations. So do this in our little example empty drawing. Well, let's just draw a rectangle. So we're going to draw rectangle, and just somewhere on the screen, click a point. And it wants to know the other corner point. And so I'm going to type at 50, 50 down at the command line. And it's going to make a rectangle that's 50 by 50 by 50 by 50. Okay. And I'll show you what this may or may not have an effect for you. Let's go to the annotate menu. And let's auto annotate. And down here, a little preview, we're just going to do angle over distance. So the bearing will be on the top, the distance on the bottom, and that's set by, it's in the row 1 above, row 1 below. Okay. And then we're going to select that rectangle and hit enter. And that now shows us the direction around our figure with the bearing across the top, distance on the bottom. And it has to do with the direction that the rectangle was drawn, which was in originally it was drawn counterclockwise. So if I make it clockwise, and I did that with this chain reverse polyline tool, which is also on edit polyline utilities, reverse polyline. And then I'll go back to annotate and auto annotate again. So now it's a little more, I'm used to seeing mine clockwise. So there we've got it with the bearings on the outside or on the top of the direction that the line was going, and the distance on the bottom. Now, what this setting may do, if you'll grab the rectangle and just grab one of the corners and just sort of stretch it out. Now, yours may or may not have updated your annotations. Did anybody's not do that? Okay, so everybody's was
Update.
Mine
Yeah,
didn't.
ours hasn't.
okay. So first thing to do then is let's go back to the settings menu and choose Carlson configure. And when that comes up, choose general settings. And that has to do with this object linking section over here on the right-hand side. And notice I have on link labels with line work. So if yours is not checked, it won't update those. So if you'll turn that on, now I have all of mine on. So I link line work with center line. So if I change a center line definition and it was drawn on the screen, it will update the drawing automatically. Or if I even grip edit that drawn polyline, it will update the center line file. Okay, so I'm going to turn all those on, and that's controlling that. Okay, we're getting to the part that's wrong. All right, so set that the way you like it. and then go back and do auto annotate again and choose that rectangle and then stretch out a corner, or just, you can leave it stretched out and just have it auto annotate again. And now it will update anytime you change it. But now there's something going on with this, and this was causing my surveyor client a problem. You see this distance right here, 57.75, and this one 58.05. If I measure the distance, say from this endpoint to this endpoint, notice down here on the bottom, it is 57.747. So that one's correct. All right. If I repeat that and measure from this endpoint to that endpoint, it's 58.0. Well, that one happens to be correct as well. Okay. So now it says 55.77, 55.66. All right. So that mine is set correctly now, but you could have this, and if you have updated, it got switched and nobody knew about it, so you had to go back and reset this. So it's on the annotate menu and it's in your annotate defaults, and when this comes up, look on the distance tab, and where it says decimals, if yours is set to 0.05, that's the part that got reset. And you really, and if it is set to 0.05, now watch when I change this just slightly. So the dent. Let me now auto annotate. So that says 56.80. And if I measure that distance, it is 56.795. Well, okay, that would work for that one. If I look at this one, it's 55.662. It ought to be 0.66, but it says 0.65. Well, that's what that setting was under my defaults. If it is on the distance tab, if that's set to 05, that means go to the nearest 500ths, regardless of what it is. And so my surveyor client was he was noticing that his annotation wasn't matching things exactly right. And it was messing up his survey plats. So did anybody find that yours had been set to 0.05? Or anything with that?
Yeah, ours is actually set to AutoCAD units, so
Okay, so yours is set to that. That's good. All right, that would work there as well. Okay. So if it is set to something with that 5 in it, it's going to give you that round off, and you need to set it either to AutoCAD units or to 0.00 or 000, however many you want. And then now when you go back to auto annotate, now you see it kept that one 80 because that was correct, but this one now says 66 instead of 65. Okay, so that's something that might or might not work. And it's on that annotate defaults, distance tab. Just make sure it is either AutoCAD units or it is one of the non-5 number. Otherwise, it will round it to that nearest 5 in whatever decimal place you choose. Okay. Now, in the IntelliCAD version, under settings, let's look at the settings explorer. And let's look under see, do I have annotate? Might be under survey. Let me see where it is. I've got it right here. It's under survey, under right here. It's under general points, draw locate points. So let's go down here to general points, draw locate points. Now in the IntelliCAD version, at least in older versions, I think this has been fixed now, but this value right here in this column under decimals, that's how many decimal places to display. There's a default and there's whatever one you want. And normally, or not normally, but I think by default that says LUPREC. Does anybody have that? Does he have this setting right here?
What did you click on after you went to general points? Sorry, guys.
I was in the settings explorer and I'm down under general and points and draw locate points. So what it normally has in it is right here under default. It defaults to the, and these are the AutoCAD units, that stands for linear unit precision. So whatever you have set in right here, the display precision, that LUPREC is a special variable name that means read this number and use that number for that particular setting. And I'll go back to my settings explorer. Let it come up here a minute. Go back to general, draw locate points. So that normally would have set as LUPREC. And it also said LUPREC over here. But the older versions of IntelliCAD ignored that LUPREC variable name. It didn't cause an error because they knew that was an AutoCAD variable, but it didn't honor it. It just ignored it. So you had to set a specific number in that. So I think the new versions now, this has specifically numbers. I think it goes ahead and reads that and sets it to whatever it is set to, and then it's whatever you want it to be over here. So just set those to specific numbers, and that's the number of decimal places that you want to see displayed. Okay. So, and again, that may have been fixed in these newer versions. I think it has been. but just double check that. Those are a couple of things that you want to make sure you've got. All right, now let's go back to settings, Carlson configure, and talk a little bit about some of this behavior. Let's go back to general settings. And here's where you can turn back on if you want to use that startup wizard. Yes, if you've turned it off, this is the only place to turn it back on. A couple of things to be aware of. Right here, you're going to look at mine under use software rendering. It is checked on. And there's a reason for that on mine. Yours is probably best left off, because if you're running on a Windows computer, you're going to be able to use the hardware for the graphics card. And that will generally be faster. But I'm running this, if you may have noticed over here, you know, I'm on a Macintosh. Okay, so, and I'm running this software on a Windows emulator called Parallels. And because of that, it won't use that hardware. It's isolated from the hardware. So I have to turn that on mine. So leave that on for yours. If you are using annotative scaling, then that's going to, based on when you change scale, the text will change height so that it always maintains what it's supposed to be. But that's more useful for if you're producing finished drawings for plotting, that's going to be helpful there. If it's not, it takes a little bit of processing overhead, so it's best to leave it off if you're not worried about using annotative scaling for your text. And you know, you would just, if you were to change the scale of the drawing, you would just go back and re-annotate things that you needed to have it change. All right, now, a couple of other things here. We talked about this object linking, and you can see what they will do. Linking points with coordinate file. So if you move a drawn Carlson point in the drawing, it will automatically update the coordinate file. And vice versa, if you update the coordinate file, it will update the drawing if that's on. And these are not something that if you've drawn something with them turned off and then you turn the switch back on, it doesn't then magically become that way. That's why you had to go back and re-annotate this after you turn linking on. It's whatever is in effect when you create the entity that these apply to. Okay, but these are generally best left on. Now, this other one to use, to be aware of, is this removing arcs methodology and these numbers right here. And what these mean are, if you have a true arc, let's say a curb return into a parking lot, and in plan view, that might be a 15-foot radius. But in the real world, it might start at elevation 100, and by the time it gets to the end of the curve, it's up at elevation 101. So that's not really a two-dimensional arc. It's sitting in three-dimensional space. But when I look at it straight down in plan view, it still looks like an arc. Okay, so when I go to model that as part of my surface, it needs to be able to convert that two-dimensional arc into a three-dimensional equivalent. And when it does that, it's going to do one of these two methods, the max offset and the chord length method. Now, go ahead and leave your settings up here. I'm going to exit out of here and illustrate that with a quick example. I'm going to just draw an arc here. I'm going to draw here to here. I'm going to put an arc in. Say like this. And then I'll go back to line. And let's say 50 feet. All right. So that and this is a two-dimensional polyline. It is at elevation 0 all the way around. But let's say I wanted to make that into this three-dimensional object that I can create a surface from. So let's say I'm going to 3D data menu, 2D to 3D polyline. And I'm going to say by start and end elevations. So it'll just be, so I'm going to select this polyline. And that starting elevation, let's say I'm going to make that 99.87. And the end, I'm going to say that's, say 102.4. And then I'll say enter. Now I've created a 3D polyline, and vertex 1 is at 99.87. Vertex 2 is 100.426, 459, all the way around until we get to 101.182, and then it goes to 102.34. All right, so it did it as we had intended, but it did it by replacing this arc, which was a true piece of a circle, with individual little horizontal segments. Okay, and that's the only way it can do that, to be able to model this. And each one of these little vertex points is going to be, when I build a surface, part of a triangle. It's going to be a corner of a triangle. It goes out and finds other things here and other things here. Okay, so here's how this works. Still 3D. Still. Yep. Let me undo that. Well, can't seem to make it undo. I guess it's got to go through every vertex. There we go. So now when I select it, it's back to being a 2D polyline. Well, let's copy that from there to there. I'll select it and make that original one red. I'm going to now put it in the back so that my yellow one's on top. I'll go back now and 2D to 3D, my start and end. And I went from 99.87 to 102.34. All right, so now what I have, if I zoom in right here, there's that original one that's 2D polyline. And there's the one that is the 3D polyline with all the different segments. All right, so what has happened is this. Right in here. Let's go from the point of this to that radius. It's 0.0051. And I also go from there to there. That's like 0.8. All right, so what we have measured now, let me change both of those scale wise. Let's see. Do this overall scale. There we go. Now, what we are measuring here is the offset. And what we're measuring here with this one is the segment length. And that is these values right here. Which method do you want to use? And it's saying, I'm telling it that when you convert that to a three-dimensional object, I want to make that maximum offset, the amount that I'm willing to live with that being off of the original circle. I want the maximum deviation to be 0.02 of a foot. My chord length, that's this distance here of that segment. I want it to be a maximum of 0.25. Actually, it's not. It's like 0.8. So if I were to say, have said chord length instead of maximum offset, it would have calculated that. So instead of being 0.8 as the chord length, it would have made it 0.25, never any larger than that. And so that would affect whatever the offset would be. And this one is lower than that 0.02. And it made the chord length be whatever it needed to be. Okay, now what that means is this one. That, remember, when this converts to a 3D, each one of those points becomes a corner of a triangle. So if I have other things out here that it's going to try to connect to, let's say I've got a 3D polyline over here, and that was, let's say maybe that one was 100. And that was 101. All right, so that's now a 3D polyline. But if I were to build this as a surface, it would draw a triangle from this point to this point, back up to here, and then from this point down to here, this point down to here, this point down to here. And at some point, they would start going over to this endpoint. Okay. I could have a bunch of points along here, and it would be a little bit more linear in terms of the shape of those triangles. But the key point is here that the more of these vertices that you have in that resulting 3D figure, the more triangles you're going to have, and the more complex your surface will be. Now, the trade-off would be if you had this 3D element, you could make it something like this. It went from here to here, to here, to here, and to here. If the numbers in your settings are such that it allows that much of a deviation or this length of a segment, then you would get far fewer triangles. You would just get one to here, and to here, and then maybe one to here and up to here. So it'd be far fewer triangles, but it would not be very accurate. Okay, so you would be what, 8/10, that would be, what is that distance from? See, that would be 50 feet. So that's missed that circle, that curve by 50 feet, and it wouldn't model correctly. And you wouldn't see it necessarily. You wouldn't maybe notice it if those numbers are too big and allowed something like this to happen. But when you go out there and try to build it with your machines, it's going to build exactly what that surface has in it, which is going to be this. And what we want it to be is that. Okay. But you also don't want this to be, thousands of more points than are necessary. So that's why you need that setting to be something that's close enough to live with. It's not, I think the default here used to be something like 0.0001 that the programmers put in. Well, that makes a very accurate 3D version of that original arc, but it makes too many points. They're unnecessary for that number of triangles. And it sort of slows down, all of the computation. So make these something you can live with. Now, your choice as to which method is employed is entirely up to you. I happen to be able to visualize this as a maximum offset better than I can with this, because and it depends on how severe the curve is and all that kind of stuff. But if I use chord length, here's an instance of 0.8 is 4, well, not quite 4, 3.5 or so times bigger than my number. So it would have made 3.5 times more points in there than it did, and still keeping it within that amount of offset. So whichever method you can use, you tell it which one you want to use, and just make sure that these numbers are something reasonable, like what I've got set here. Okay. And that's really about all we need to worry about on those general settings. We'll talk about these takeoff and sight net settings here after lunch when we come back, and then we'll start playing. But we'll talk about how this affects the behavior of our modeling. Okay. So with that, you can save that drawing if you want, if you've done anything or not, it doesn't matter. We'll come back and use some other drawings after lunch. Okay. Questions on any of that? Everybody good?
Looking good, man.
Okie doke. Well, we'll pick this back up right at 1 o'clock. I'll go ahead and turn the share off, and I meant to pause it, but I'll turn it back on later. I'll pause the recording. All right, I'm back whenever you guys are. Just give me a yell.
I'm back.
All right. It looks like we're all back. Jason Downs, were you back? I saw the frame light up.
Yeah, I'm back.
Okay, sounds good. All righty. Hope everybody had a good lunch, or if you're like me, you wound up spending an hour answering emails and phone calls, but regardless, let's talk about a couple of the next things. Let me ask you guys, you can go ahead and unmute and let's discuss a little bit here. How familiar are you all with some of the stuff that we've been going on? I don't want to get too deep into the weeds on some of the preliminary stuff. But like, are you all familiar with using coordinate files and line work and stuff like that?
Just on my end, my limited experience with survey and everything, all we did was basically upload said coordinate file and generate points and everything from that. And that's when we started our boundary work. So.
Okay, yeah, but I mean, but you know how you know what a Carlson point is.
Yes.
In the drawing and all that, and how to deal with point numbers and such like that. So.
Yep.
All right. So I think what we'll do is talk about how familiar or unfamiliar are you all with building a surface model, just in general? Like
Zero experience.
zero. Okay.
Been working on it. Just ain't. I'm trying to get more efficient at it.
Okay.
Yeah, I normally have other people do it for me, so I have minimal experience.
Okay. So
Great surface, but as far as doing a whole lot of manipulating on it,
okay.
I guess swap
Yeah.
edges is about it.
Yeah, good. So what we'll do is we'll talk about what goes into modeling a surface and how we can do it. So we'll spend a little time with that. There's a couple of other things I want to make sure that we get to, and that is I've got some sample files in your data sets that are that we can construct out of a PDF. And I know some of you guys were talking about once you're awarded a project, you can get the original source files, so you won't have to worry about converting, but I think you need to see what goes into that conversion process. So we'll take a look at some of that kind of stuff. So for now, let's go back to if you've got your manual, your training manual open. I want to go to here it is on page 18 and 19, called Surfaces and Contours. It's terrain modeling idea. And we'll talk about what goes into building a terrain model and the concepts of things like break lines, what they are, how to use them, how and when and where to use them, that sort of thing. So I'm at that page on the in the manual, page 18. Now, basically what we do when we build a terrain model is we've got a bunch of things in our drawing, and mostly they are points and lines polylines that have an elevation assigned to them. So like a polyline, an example of one might be a contour line. Let's say you've got the 108-foot contour line, then that polyline needs to be sitting at elevation 108, okay, to model that ground to the same scale and same reference. So sometimes what we have to do is to take a drawing that is just like a PDF, everything's down at 0 elevation, and we'll have to assign the elevations to those items. And we're going to see some tools that help us to do that real quickly, or rather quickly, or relatively quickly. But what goes into building the surface itself? And if you want to, on your own time, I'm not gonna read you this whole business here, but this is the basics of every bit of what we do in Carlson software. Even in terms of like surveying, if we're going to generate a contour map, then we need to model that terrain. So if you look at a normal drawing, we'll see the edges of roads, top of a bank, and bottom of things like that. But we need to make those drawing elements help us define the shape of the surface that they are sitting on. In other words, the ground. In the case of existing conditions, it's things that are on the ground, on the existing ground. In a design situation, it's going to be what gets built. And so it would be the new ground, if you will. So, so the way we do that, let's see, if we have just a bunch of drawn lines and points, then we have elevations on all of those things, but we don't know anything about the elevation of the ground in between those things, or in the empty spaces in between them. And so that's what building a terrain model is going to do, is it's going to create a continuous surface that incorporates all of those things in between. So we do that with this process called triangulation. And it's going to take everything that we select and read the elevations, and if it's a point, a Carlson coordinate point, or if it is a polyline that's drawn and it has vertices in it, and each of those vertices are set to a specific elevation. So it reads all of that point data and starts to create triangular pieces, triangular little triangles in between all of those points. And like it will build a triangle here, and it'll go out here and look for other stuff all around the outside and start making triangles. And it uses a triangle because it takes 3 points at a minimum to define a planar surface, a piece of a plane. And so in this case that you're looking at right here on the screen, here's 4 points, and it makes triangles in between them. And so the edge of, say, this left triangle is going to also be the same edge as this right triangle. And in this particular case, you can look at the elevations. It goes from 110 to 110, and then it falls off to 100 on this side, falls off to 100 on that side. So that makes sort of like a little ridge. And those 2 triangles would then form part of that surface around those 4 points. Okay. Now, and these particular lines, these are things that the computer builds in memory. You don't draw those, it's going to generate those. But now, imagine that instead of this being a ridge or along this 110 that falls off to 100, maybe really it looks like this. There's the same 4 points, but it becomes the floor of a valley at 100 feet here, and it rises up to 110 on each side. Again, the same 4 points. If I can get this to zoom here a minute, hang on a second. So those same 4 points, and it can either form this ridge or it can go this way and form the valley. Now, if we don't tell it anything otherwise, it's going to be free to choose whichever one of these that it gets to first. And it may find this first as it builds this triangle. And once it does, it no longer has the ability to go from this 100 and go over here to this 100 and make a triangle over this way, because it has this edge already built and it's in the way. It keeps this 100 point over here from seeing this 100 point to allow it to create a triangle edge across it. So in the case of just having 4 points, we're sort of at the mercy of the computer, and to whichever order it finds, whether it finds this first or whether it finds this first, we're at the mercy of whatever it does to how it defines the surface in that region. So if we know it's a ridge line here, if we go in and draw that 3D line in there ahead of time, then it's already drawn and it won't form across it. It will protect it. And that's what we call a break line. Okay, and it's basically up here, we talk about it in this paragraph right here. We talk about every triangle edge it forms, it's a line of linear change. It's a constant rate of change from one point to the next point. So halfway down between 100 and 110 would be 105. All right, so that's a concept to keep in mind. But then if those 2 points don't lie along that straight line change in grade, we have to separate them with what's called a break line, or by enough additional points, like some in here in the empty ground, that it helps to define that. So we're going to have this concept of using a break line, and we're going to create barriers, because we learned this rule that every point can see every other point around it. And it therefore can possibly form a triangle edge with those other points. Okay, it does that with an algorithm called Delaunay's criterion. You don't have to worry about the details of that, but it follows a set of mathematical rules as to how it finds those. So if it doesn't have anything drawn in between ahead of time, it's free to look around and see, and if it finds that other point, it may draw a triangle edge over to that point. So when we know that they're not supposed to be able to see it, for instance, if this is a point out in the road, and I've got a curb that runs over here, and this is a point over here like a tree in the field beside the road, or beside the curb, I know that this point in the road does not travel in a straight line from that point up to that point. It hits the curb. So I know to connect all of my curb points together and put them in, and then create that string of curb points as a break line to keep these points on this side from seeing points on that side. Okay, so we think about break lines, and the way it gets its name is it is a line that represents a break in grade. In other words, if I go from this 100 to this 100, as I cross this line, that's going to be where I have to go from 100 up to 110 and back to 100. So it breaks the grade right there along that line. So that's all well and good, but it's sort of hard to try to visualize what that means in the field. And the real rule of thumb is simply this, that if we remember that these curb lines or edges of pavement or whatever they may be, if we remember that they're just edges, we look at this, the books all told us break lines represent a break in grade. But if we remember that they're just edges out there on the ground. So our primary rule of thumb to prep our data is that if it is an edge on the ground, then we need to make it an edge in the data set. Okay, so here's a very classic example of a situation. This is a curb in a roadway. And this is what can happen. Let's say the surveyors bring us back these points, A, B, C, D, E, F, G, H. So A and B run along the edge of pavement, C and D are in the gutter or the face of curb, E and F are on the top of the curb, and G and H are along the back of the curb. But if we don't draw the lines in between there, there's nothing that keeps point B from looking over here at point F and saying, oh, I'm going to draw a triangle up there. And in that case, it will model the ground as if it goes from B to F without going down into this low point first. But if we do draw this line that goes through C and D ahead of time, then B sees that line and it can't see this point over here for F. And so the only triangles that can form are from B up to D and B back to A, which is okay, and B down to C. And then the triangles for F would be C to F, G to F, H to F, and D to F. And those would all be good. Here's, here's an example up here of how that works. Excuse me. The dashed lines here represent some triangles that could form, but the dashed lines would be lines that are not valid. In other words, from point A to E, you see it doesn't come down into this face of curb. C to G doesn't get the top of curb. It goes through the curb and goes to the back. So to prevent that, we draw those linear features in there, those edges, and now B can't see F, can't see H or G, can only see D, C, and A. So that's where those triangles get formed, right along that slope of the gutter pan. Same thing for these contours here that are along the face. These triangles, I mean, they're along the face. So C can't see G anymore, but it can see E and F, and that triangle is correct. G can see E and F, and that triangle is correct. And those two triangles now define that shape correctly. Okay. So that's the concept of using points and lines, or what we call break lines. These are lines of connected similar features. And here's a snippet of data that was taken from a photogrammetrist from an aerial mapping compilation. And they recognize these lines out there on the ground as all lines that are sort of edges, including these edges of the driveway and the edges of the roadway out here, so that points on this side of the road can't look across and connect triangles to the other side. And we can look at it like this, and you can see all of those things in 3D. If I rotate this around, are going to look like this and help define that data. So we're going to really follow this rule right here. We're going to look at our data and make sure it is correct. Okay, and we're going to use our eyes and our senses when we look at these things to make sure that our data is modeling the way we want it to model. Look at it up here. We can, use your eyes to see what that looks like. Okay, and there's other times if you spin this data up and look at it in 3D, this looks all good. The stream comes down the center of the stream. The roads are where they're supposed to be. But if I spin it up and these things are sitting down at 0 elevation, then I know that these are not going to be valid until I give them elevation up here, or from a survey or from some other means, so that it knows when it hits those edges that it can't look across and it's not going to form triangles. Now, if I had a situation like this on the right, where these are down at 0, these are up at some elevation, and I'm looking at it in plan view and it looks like this, it all looks okay. But if I go to try to model this as a surface, I'm going to get, triangles out here and out here and out here that are fine. But when it sees these elements, it's going to try to draw triangles down here to 0 elevation, and you're going to get some really strange results. And so that's what we're going to always be looking at, is to make sure that everything that we want to use as part of our surface is at its proper elevation. Okay. Some other places where we need some break lines are around the outside edges of our data. If you can tell the color difference here, the black, the black is the actual data. That's the edges of the road and the center line and out to the edge of what they collected. But you see points along this edge out here, because there's nothing drawn between that point and points up here. It can form all of these triangles out in here in this area. But we don't have any data out there in reality. So we need to draw an edge, this boundary around the edges, to keep these points from looking over and seeing these points. Okay, and there's several ways to take care of that. We can let these form, and then we can erase those triangles, or we can say, don't make any triangles over a certain distance long. But the best way to control that is to draw the edge around all of our data and make it contained within that drawn shape so that it won't form on the outside. Okay. And so that's how we control what we're going to be doing. Now let's look at an example of this, and we're going to, let's open a file. We're going to go back to Carlson. We're going to open a file. And we're going to go to our folder, and we're going to go to this folder inside of it called Getting Started. And we're going to find this file right here called Sample from T3 Global. And let's open that up. And once everything comes up. All right, so now we've got a drawing here. Everybody up at this point, okay? Okay, so what I want you to do next is let's go to the view menu and choose freeze layer by pick. And go out here on the outside edge and just click on one of those white lines so that it turns that layer off. Okay, and then that looks more like what the map should look like. All right, now this all looks fairly good. I can see I've got some points down here and around the edges. You can see some of them up here in the top too. See those pink looking points? And those are just points. They're like lines and points and such. They're not Carlson coordinates. They are just CAD points. In fact, if I select one, I look at it in my properties, I see it is a point. And it is a point and it has a particular elevation on it. In that case, 1335.16. Okay, so those points are all good to help define the surface, but I also need some additional things to help define the surface. And let's take a look at what we might have. Let's go back and choose that same command, view, freeze layer by pick, and zoom in and pick one of the major contours, one of the minor contours, and do the same thing in these obscured areas, the major and the minor. So now you should have something like this. Now, if I wanted to make a surface out of my compiled data, and these could be, all of these points could be points that the surveyors gave me. In this case, the stereo plotter operator at the photogrammetry firm compiled these on a machine and gave me those elevations. And I see things like this. I see, you know, this road edge here. I see some curbs in here, some buildings. But if I don't have these drawn edges, see right now that edge of the pavement, if all I'm using are the points, and let me turn the points on so you can see them a little better here. I'm going to use just little plus marks. Let me make them a little bit bigger. All right, so if I just use these points and I use it to create a surface, there's nothing that keeps this point here, for instance, from looking across the road and seeing this point and this point. Okay, and vice versa, all the way across. So I need to have something along that edge of road drawn in my drawing to keep that from happening. And you may think, well, I've got them. Here's one and here's one. However, when I select those two items, I look over here, I see they are just polylines. They're not 3D polylines, and they have an elevation down here of 0. So what I need are the lines. Let's say they surveyed a point right down here and a point up here and a point up here. I need to connect all those points with their elevations so that when it forms a triangle, this point can look to this line and find the elevation of this point and the elevation of this point and make those triangles, saying that this point can look at this line and start making triangles up to those particular points. But it needs to know what their elevation is, so it makes a valid triangle. Otherwise, it would go from this high elevation down to 0, over to 0 and back up. Same thing here, it would be a mess. Okay, so here's the way some of that would turn out. Let's go to a command on the surface menu, and I'm in civil. I'm going to go to the surface menu and I'm going to choose triangulate and contour. And that's going to bring up a dialog that lets me build a surface from the data that I select. And I'm going to look on my selection tab and I'm going to uncheck everything in here up at the top so that it's all grayed out. I don't want to limit my selection. Okay. I'm going to look at the contour tab next, and I'm going to uncheck draw contours. I don't want to draw contours right now. I'm just going to look at my surface and see if I got problems. But you can do that all in the same step. You can draw contours and label them and everything else. So if I uncheck the draw contours, then everything on labels is grayed out because I'm not drawing anything. I'm going to go to the triangulate tab and I'm going to control the triangulation. You could have it draw the triangles if you wanted to. There's no real need to. We can always see those with their 3D viewer. Same thing with using 3D faces. But I do want to turn on this write the triangulation file. So when I do that and I choose the select button off to the side of it here, I'm going to show it what folder I want to go in. In this case, I'll keep it as my getting started folder. And I'm going to call this EG-bad -1. This will be the first example of a bad surface. And I'll say save. Okay, so all I've done is tell it what file to use. Now I'm going to say, I'm going to uncheck this use inclusion and exclusion areas. And I'm going to set my shrink wrap perimeter reduction to none. And I'm going to uncheck ignore 0 elevations because I want you to see what happens with that. And then I'm going to densify my break lines. Let's put them every 20 feet. And I'll uncheck a couple of things down here. So the only thing I've got on is densify break lines for every 20 feet. And I'm going to say, okay. And now I read my prompts and it says select entities, but read the line above it. It says select the points and break lines you want to use to triangulate. Well, I may decide to select all this data. So I drew a window around it. I hit enter to finish that selection. And it gives me some errors. I've got right here is a line that crossed, and right here is a vertical edge. So right here is where the line crossed, right there. And if I zoom in, see there's a drawn line in there. Right there where that line hits that line, and it says it is 714.378 difference in elevation. All right, so that's one place I need to fix. Here I've got a vertical edge of almost 1,300 feet. So if I exit this for a minute and take a look at that, I'm going to select this polyline. I see it's at elevation 0. That's just an inlet. Now select this polyline, elevation 0. So these are all at 0. That's fine. But if I select this, I see that it is at a position of almost 1,300 feet. So that's in a place where it's going to, that's why we got those errors for those vertical drops. Because it tried to go down to 0 and hit that. Now I've got some other triangles over here that went from here down to 0, but it didn't cause an error because it wasn't conflicting like this one where it crossed something at 0 and something in elevation. Okay, now let's take a look at that surface and see what a mess it made. And you could have done that by drawing the contours and looking at the contours, but better than that, let's go to our viewer. It's on the view menu, 3D view, surface file viewer. And when that comes up down here in our recent files box, we're going to select that EG bad one, and we'll choose open. And we look at what comes up, which is going to take a while because we got a bunch of problems. So hopefully it won't take that long. Just let it cook a little bit. Here we go. All right, so there we go. And I'm going to go to my settings menu. I'm going to turn off this contours. Let me go back to my view control. I'm going to turn off this button right here so that it's not coloring in the triangles. If I do it, it will color them in. If I take it off, it uncolors them. And now, if I move my cursor over in here to the middle, make sure I choose this icon right here with the spin the little cube around. And if I click and push it up, you can see all of those places where these triangles that you can see up here on the top are probably okay. But it also found things down here on the bottom, and it tried to create edges between those in the top and those in the bottom. And that's a real mess of a surface. If I look at it again in 3D, that surface you can see is just awful. Okay, now let's close that. And let's look at something that we can use. If I look at these edges, which are down at elevation 0, and I realize that my triangles formed from these points down to those edges, if I don't want them to form there, I'm going to go back to surface and choose triangulate and contour again. Keep everything the same, except I'm going to check ignore 0 elevations right here in the middle. Now I'll say, okay, it's going to ask if it's okay to overwrite, and I'll say, yes. I'm going to overwrite that file. I'm still going to keep it there. Now select things that I want to use. I'll just select them all again. And this time it comes up and didn't give me any errors because it's not, it didn't consider this that was down at 0. It only drew the triangles around things that have elevation. But remember this area in here and maybe this area across the roadway. if we look at our surface, again, 3D view surface file viewer, and we choose that. Now it looks a little bit better, but I'm supposed to have a road over here. And there was that road and those curb lines and such in between here that I don't see. All I see are the triangles that formed between each of those points. Now I'm going to exit that and I'm going to show you if I select all this data again. I go back to my view, 3D viewer, drawing viewer. I've got this same box up here that says ignore zero elevations. Those are the things drawn at zero elevation. But if I ignore them, then this is what built that surface. Okay, so I'm going to go to the model tab, turn off the layers that used to be up here. And I'm going to go to the surfaces button. I'm going to right click and choose add surface. So I'm going to bring this surface in and look at it along with those points. So I'm going to bring that surface in, go back to my view control, and I'm going to click this thing here that turns the surface on. And you can see, well, those points along the edge of that little pond over here look okay. But I've got points in here. Let's turn that back off. So I've got points, everywhere I've got these, find those purple points, they're not showing up big enough to really see. But it put those edges, those triangle edges, you can barely see the little pink points in there. You see they're along where those triangles form. And if I go back to the model tab and right click the surface and choose hide the surface, there you can see triangles formed across from this set of points over here to this set of points over there. So I'm just going to toggle that. And I'll just double click it and you can see where triangles in here should not be forming from one edge to the other because we had that edge in there with those lines that should have been at some elevation. Now, let's go back and say, view, and let's thaw/on all layers. And all of this is going to come up again. And now I want to go to view, freeze layer by pick. And I'm going to zoom in and I'm going to turn off those drawn contours. And just leave these. And if I look at this in my 3D viewer, now I'll get it from the toolbar here, the 3D viewer window, which was view, 3D view, drawing viewer. So I'm going to choose that button. And that's going to put everything here. And if I uncheck ignore zero, you can see all of that stuff that was drawn at zero elevation. But I see all of these white lines in here, and those are those compiled break lines. Okay, and so when I look at that in here, remember those blue lines, I'm going to take those two and I'm going to send them to the back. So I'm going to right click, draw order, back. Now you see these are the two that were at zero elevation, but I also have, as part of my data set, I'll put these in the back again. Draw order to the back. I've also got these that are 3D polylines. And they actually have changing elevation from point to point to point. Okay, and so that's a result of the people at the aerial photogrammetry firm putting that spot on the ground in their machine and reading what the elevation is and creating that 3D line. Now, if we go back to surface, triangulate and contour, this time I'm going to leave right triangulation file on, but I'm going to choose select, and I'm going to give it another name called EG-good -1. I'll save that. And again, I'm going to ignore 0 elevation, so I don't have to worry about going in there and freezing off those layers. It's going to ignore them for me anyway. And I'm going to say, okay. Read my prompt, select the entities. There they are. Even though I've selected things at 0, it said ignore them. I'm going to say, okay, now it does come up with a couple of problems here, like 100th difference, 400ths. And there's a couple of little compilation errors with like some head wall data that for now, we're just going to ignore it. So we're just going to say exit and let it go with what it found. And now let's go back to the view 3D viewer, surface viewer, which is this one right here on the toolbar, or it's on the view menu. And I'm going to look at that good surface and look at the difference once I click that back to a color. Now you can see my road over here, those curbs. Look how nicely defined they are. Same thing here. If I zoom in there and let's zoom it up a little bit. And I even have over in this area, see, I've got a nice, what looks like a loading dock on this building. Okay, so that's the importance of and the power of using break lines to define those edges. And again, break lines are nothing more than just edges in the drawing. And so they went through the aerial data and put those edges in for me. Okay. So I've got these retaining walls over here. I've got retaining wall here. Look how nicely defined my pond is up here, that perch pond, and here's a bigger pond. Right in here's that empty space between those points. But because I had an edge here and an edge in the center and an edge along the other edge, it only allowed those triangles to form from this edge that you see here up to the center line, out to this edge over here, and then back up to this edge. I think it's right in there. Okay, but now, what do we do about areas like this over in here and down in here? If I look at that, and I'll show you these controls here in just a minute. If I spin that up and look at it, I've got this big giant flat edge over here, and I've got things over here that just really aren't part of that surface. Okay, in fact, if I go through here and select all this data and view it with my 3D viewer, now it's the drawing viewer, not the surface file, but the drawing viewer. And then I go to my model tab, close off layers, right click surface and add surface. I'm going to add the good surface now. And what can I tell immediately from this? In fact, if I put uncolor the triangles, you see these triangles down in here along this bottom edge and over here. There's no data over there. It just formed because these points along this edge could see these points up here. These points down, this point here could see all of these points, and so it drew all of those triangles. So the way that you need to limit that, keep that from happening, is that we need to draw a boundary. So if I go over here and turn my surface off, you see down in here where it's empty over here. I need to somehow draw a boundary around my data and say, you can't look past that line. All right. Now, before we leave this, let's talk about how I'm doing all this kind of stuff here with the 3D viewer, if you're not familiar with it. On the view control tab, there's a series of icons here. One looks like a hand, and that all that does is pan the view. But this one right here, that's our workhorse icon, the 3D rotation icon. And if you look at that, and when you move the cursor into the drawing, you're going to see it change shape. Right now, it's on the edges, it's a Z with a rotation indicator. But if I pull into the part of the drawing that has data in it, you see it changes into an X and a Y. Now, there's a couple of tricks on how to be able to position this any way you want to look at it very quickly and easily. And it's this. Make sure over here that you have this middle Y-axis control locked. Okay. And then what you're going to do is you're going to visualize to yourself that you are out standing in your driveway and you're looking at, say, a garage door on your house, and it's sitting there just staring back at you. And what you want to do, if you want to reach down here toward the bottom, now don't put it so far that it turns into a Z. You want it to be that X and Y. And you're going to click and hold the mouse and push it up, just like you're trying to raise the garage door up. And go back and get another bite if you need to. And you want to roll it. You want to pull it up to its fairly oblique. You don't want it, too high like this, but just something like this. And then you want to put the cursor down toward the bottom so that it's the Z rotation only. And now click and move the mouse and it will spin it around. So I'm going to click this icon here and go back to plan view and show you. Let's suppose I want to look at this resulting model. I'm going to go back to my model tab and I'm going to turn my surface back on. I'll go to the view control and color it in. Now, let's suppose that I want to look at this model. I want to say, look along this wall from up here in the roadway. I want to sight down that wall. So I'm going to go get my workhorse icon. I'm going to get the bottom of my garage door and I'm going to roll it back up. Okay, I know I'm not where I'm supposed to be yet, but I'm just gonna roll it up. Then I'm gonna go down to the bottom. I'm gonna roll it around until I'm lined up with where I want to be, like right there's where I want to be looking. And then I'm just going to point the mouse and roll the wheel on the mouse. And, then you can use it to fine tune once you're in like that. And then if you want to change your views, just roll it back out, spin it back around, and maybe say, look down this roadway. Or come back around and you want to identify this little parking lot area in here. Okay, so you'll get used to that. It'll become second nature to you in no time. Now the wheel on the mouse will, let you pan. You can press and hold the wheel down and pan it over, same as if you grab this icon and did that. Okay, but just use the wheel just like you do in the CAD drawing. And then the X and Y and the spin to get lined up, get oriented the way you want it to be, and then zoom in and out and pan things around. Let's see if I want to look, say right up that little channel right in there. Or if I want to look at this pond. Okay. Now I'm going to exit that. And now let's talk about how we draw a boundary around our data so that it doesn't form those triangles out in here and out down in here. And we could do a couple of things. We could say, just draw a polyline, and it can be a 2D polyline on those boundaries. So let's say I want to put this on a layer called BDY for boundary. And I'll say, okay. And I can just do something like this. I can go from here to here, to here, to here, to here, to here, to here, up in here, over to here, and then say C to close. It has to be closed. All right, so now I've got a closed boundary that I've drawn, and I can adjust it a little bit, maybe pull it in like so, maybe come in here and say add a vertex up here, hover the mouse, add a vertex, say down in here. So you can tighten that up if you want or need, or just leave it like it is. Now, what's going to happen when we build this surface, and I'm going to go back now to my surface menu, triangulate and contour. I'm going to choose select for my right to triangulation file. And I'm going to make this file called eg-good-2. I'll say save. But now I want to click right here to says use inclusion and exclusion areas. And those are going to be closed polylines. And when I tell it, hey, I'm going to use these sets of polylines to be inclusion areas and these other polylines to be exclusion areas, and they're going to control the surface that results by limiting it to those boundaries. And over here, where it says boundary method, you can either trim the edges at the boundary, which is what we want, or you can remove any of the crossing edges. And what that does is if there is a triangle that starts in here and goes outside of it, if I weren't using it, if I said remove the edges, it will leave gaps around those edges. It takes out the whole triangle. So I want to trim the edges at the boundary. Now I'm going to say, okay, but watch what happens next. It says select entities, and we used to just draw a window around it to tell it what we're using, but read the line above it. It says select inclusion perimeter polylines or press enter for none. So I'm going to select this. And I'm through selecting. See, it lets me select more than one because you could have, independent areas of inclusion and it would just ignore the stuff that's not covered. We'll show that in a minute. So I'm through selecting any inclusion perimeters. So I hit enter and continue reading the line above. Now it says select exclusion polylines or enter for none. Well, I don't have any. I'm going to say enter. And now select the points and break lines to triangulate. So I'm going to select all this data. And even though that's drawn, but it's at 0 elevation, so it gets ignored. And now, and again, those compilation errors we're going to ignore for now. So now when I go back and view my surface file, notice those areas have been cut out and you no longer have those extraneous triangles that were built, edge to edge, edge to edge. Now you still got some that might not be valid because again, it went from everything it could find, but stopped along those edges. So you could have, a couple in here that don't make sense, that you need to tighten that up, that sort of stuff. All right. Now, let's do a couple of other things. I'm going to select that boundary. I'm going to delete it. And let's draw a 2D polyline. Say, okay, and I want you to just click something sort of arbitrary. I'm going to close that. I'm going to repeat the command. And I'm going to come over here and draw another shape. And let's go back and say surface, triangulate and contour. Again, using inclusion areas, I'm going to change this file name now from good 2. I'm going to call it good 3. I'll say, okay, now again, read your prompts, inclusion polylines. I'm going to select this one and this one. Any exclusion polylines are enter for none. So I just hit enter. Now select the data. Select it all again. I'll hit enter. And again, exit that. And let's view that surface now, which was e.g. good 3. And you notice that this is my surface file. And it's not defined outside of those inclusion boundaries. Okay. Now, what about things? What about exclusion boundaries? And if I freeze by pick, I'm going to freeze off that data set for now. And I'm going to look at my drawing in a minute. And I'm going to look at this and this and this and this. Another one down here. Those are building outlines, right? There's one, but it says ruins and there's some shots on it. So it's not really a building, it's just an area. But I see that these are building outlines. Now, what do we know about the ground inside this building? We're not really able to see the ground if there's a building in the way. So those would make sense to be areas of exclusion. So what we'll do, I'm gonna go back and turn on again that brake line layer that I turned off before. And so I'm going to choose my layer control in the view menu. I'm going to sort by this freeze thaw column. And I see that it was V topo brake line, BKLN. So I'll thaw those back so I can use them again. And I'm going to draw my boundary back just sort of haphazardly. We're going to talk about this in a minute. All right, so that'll be my inclusion. So I'm going to go to surface, triangulate and contour, and I'll just leave that same e.g. good 3 name. I'll say okay. Yes, it's okay to overwrite. I'm going to select the inclusion. There aren't any more, so I hit enter. Now it wants me to select exclusions. So I'm going to come in here and select that building, that building, that building, this building. Now they're drawn down at 0. 1, 2, 3, 4, and then this one down here, 5. But again, because it's just a boundary, it's okay to be at 0. So now I'm through selecting my exclusion. So I hit enter. And now it still says select entities, but it wants me to select the points and break lines. So I'll just grab everything again. Ignore those compilation errors. And I'm going to view that surface this time. And I say, lo and behold, there it is with those areas cut out that I don't know anything about. I don't know what the ground is doing underneath those buildings. Okay, now there's a case where the building actually came out here and it knocked off part of that loading dock. So, you know, to use some judgment as to whether that needs to be adjusted or not when we're doing it. Or we could say, go ahead and, you know, don't exclude it, just consider it, you know, let it build triangles across that area. Here's where that building footprint went a little bit beyond that wall. So you could either, you know, shrink this up so that it doesn't come all the way out, or you could just simply say, don't exclude this. And again, these are drawn at 0, so they don't affect the triangles other than to limit them on or off. And if we said triangulate and contour, we'll keep the file name the same. We'll select our inclusion. Now, no exclusions. And then select the data. I'm just going to type ALL for all. Ignore that. And then go back and view that file. And now when I look at that, you see I've got the wall came up there, but I didn't. And I've got over here where this building is in the back. But it just assumed edge to edge and just sort of created the triangles all the way across edge to edge of the building with a straight point in there maybe. Okay, and that may be sufficient to what we want to do. Now, what happens when you have exclusion areas and you've got holes in your surface, like we did the last time? Anytime you go to calculate volumes between this surface and let's say that building gets torn down and you're putting part of a parking lot or a road across it, it won't calculate volumes in there because one surface is missing. So it doesn't have a comparison. So in that case, you might want to have it form the surface within those outlined buildings so that you could, in fact, get valid numbers within those areas. Now, one final thing to talk about here. I'm going to select that boundary that I drew and I'm going to hit X, or I'm going to delete it. If we don't want to click our way around our data, and we want a quicker way of creating that boundary, we have a tool on the draw menu called shrink wrap. Shrink wrap entities. Now, don't be confused with this command, boundary polyline. The two are sort of inversely functional, if you will. I'm going to go ahead and I want to show you that difference. I'm going to go up here to the side and I'm just going to draw a couple of things. I'm going to draw a rectangle. I'll draw this shape like this. Close that. I'm going to draw a circle. And I need to turn that into a polyline. All right, now that's one's white, one's yellow. Let's make this one green. Just so you can see it. The difference between draw shrink wrap boundary or shrink wrap entities or a boundary polylines. Shrink wrap is from the outside in. So if I choose that, and I'll put this on this layer here, and let's say bounded line work only for this example. I'll say, okay, and I'll select those items. And now the thing that it just drew is this. So it went and looked at everything we selected and it started from the outside and it drove in until it hit those edges and it created the boundary from the outside in, okay? Now draw boundary polyline, which even though it says boundary polyline, we think that's what we want, but this is a different feature. This is a CAD feature. And if you know about drawing hatches, that's what this is. And this goes from the inside out, and it's a boundary around what would be a hatch if I were to hatch this area. So if I draw a boundary polyline, and let's put this also on boundary. Let's hit okay. And I'm just going to pick a point in here. Now, this, if I make that also so you can see it, that whatever point I pick, it's going to, as if you were standing in a bunch of walls and you had a spray can in your hand, a spray paint, and you painted all the inside walls that you could see. So it found all the edges of these shapes and it created that boundary there. So that's not the outside boundary, that's a shrink wrap. Boundary polyline would be, this would be the boundary of a standard hatch, as if I had hatched this area here. Let's make that bigger. So that is my hatch, and the boundary that it follows, that's that boundary polyline that other command just did, okay? Now, that is useful for certain things, like if you need to figure out the total area of these shapes, but not have to subtract this area in between. So if we draw a shrink wrap around that, bounded line work only means it has to be closed. It's not going to jump across gaps. We'll talk about that in a minute. And if I select these objects and then select that resulting object again so you can see it, then I could, I could then select this and look at its properties, and I see down here that it has an area of 33,644.05 square feet. So if I've got like phase boundaries, or if I've got, a building here and something else there, and I need to get that total area, but, otherwise I could calculate that area, write it down, calculate that area, write it down, calculate that area, write it down, and figure out the parts that overlap and subtract them, or I could just use that shrink wrap and get that total area. Okay. So that's how that part works. The difference between shrink wrap and boundary polygon. Now, we're going to use that same deal by draw shrink wrap entities, but this time we're going to say across gaps, because we've got these ends of these lines out here. We want the line to shoot across that gap and shoot across all those gaps. Okay, so that it doesn't try to turn in and find a solid edge. So we're going to let it go across the gaps, but now we have to tell it, how do we want to reduce the perimeter? And let's start with it to be none. We'll say, okay, we'll select all of our data and enter, and there's our resulting line. But looks good up here, found across there, okay, but what happened right in here? See, it went across the gaps, but it left this area that we've been trying to eliminate. So I could, do something like this after I did all that. To sort of reshape it, but that's a pain in the butt. I might as well just draw it. So that's called no perimeter reduction. And here's what's actually happening. Just to draw that line, it actually does a triangulation, just like we did before on surface, triangulate and contour. It does all that in memory. And then it creates all of those triangles. And then it wants to know the perimeter reduction. It means, how much do you want to get rid of these outside edge triangles? How much do you want it to try to work to get rid of them? I said no reduction, so it didn't do it. So it created all those triangles in memory, and then drew this around the outside edges, and then threw all that stuff in memory away and left me with that. Okay. So let's do it again. Shrink wrap entities. And now, instead of no reduction, let's do a high reduction. And we'll say okay. And we'll select our data and look at the difference here. Now you see it goes in and it really hugs the data. Okay, in fact, right in here, like this might be a little too much. I might want to get rid of a few things so that it goes ahead and lets it, form data in here instead of where it was before, right here, it clips that part of the surface out. So what I want to do, and again, you can see up in here, where it jumps in, jumps out, jumps in and out, in and out, in and out. It's a little too choppy. Now that would work. That would certainly limit our surface. But like right in here, for instance, I've got a point, I've got these purple points, and it comes up here to this point. Now, see, I would rather have it do this so that it would include those points, but also include out to here. Okay. So our goal then is to find a happy medium. We'll say draw shrink wrap entities, and this time instead of high, we would choose low or medium and see which one gives us our best results. And if I said medium, say okay, I grab all this. It's still somewhat choppy. It's not as bad as it was. Okay. So I'll try it one more time. And I'll say low. Oops, let me get everything here. And now you see it's a lot smoother around those edges. And there's still some things I might want to modify here. I may want to add, a couple of spots in here. And that looks pretty good there. You might, you might want to remove a couple of those in there. For instance, I'll go up here to my remove polyline vertex tool. I'll hit this and I'll just start clicking a couple of points in there, maybe get rid of that point. And so now we'll come out here, and so it will create data in there. And there's a couple of other spots. So, you can fine tune this as much as you need. But here's where some engineering judgment may come into play. When we're trying to model our data, we need to ask ourselves, where are we working? Maybe that's the extent of where our work is. And even though we have data out here, we may not need it. And so we wouldn't necessarily need to model that out there. So if we shrink wrap our data, and no matter how tight or loose it may be out here, if I'm not working on those edges, I don't particularly care about that. I'm not going to come up here and fuss around with little things like that. Okay, or getting rid of that one. I'm just going to let it be what it is, knowing that I'm not out here on the edges, I'm in here in the middle. Okay. So that's one way you can do it. And you can draw this and leave it drawn in your file and use that to select your inclusions. Or one last trick. I go back to surface, triangulate and contour. And now, instead of use inclusion and exclusion areas that we've been doing before, if I uncheck that, notice I've got this command that says, well, shrink wrap perimeter reduction. So what it's going to do is when I select this data, it's going to take care of drawing that shrink wrap perimeter for me. And again, I can use no reduction, low, medium, or high. I'm going to say low because we found out that gave us our best results. I'm going to hit this setup button, and this is where you can decide whether you want to draw it or not. I always draw this so I can visually inspect it to make sure it's okay, but you don't have to. I'll make it 2D just for simplicity's sakes. I'm going to select that same layer. I'm going to say okay. And I'll say okay to this. Okay, to overwrite the file. I'm going to select my data. Now notice it doesn't ask me for those inclusions. This time it just wants the data. So I'll take that and I'll say okay. Again, ignore that business there. And you see I had it draw the inclusion and exclusion area. And I let it do that for me as part of that process. Now you can do that as the first pass and then come in here and again, modify, however you might want to do it, and then go back and build the surface again. But then instead of letting it do it for you again, then turn this on to use it, then select it and select your data. Okay, now it's, oops, except it erased it. So that didn't work. The reason that erased was here on my triangulate and contour control. I said erase previous contour entities, and even though that wasn't a contour, I said it should say all surface entities, and that was a generated surface entity. If I turned it off, it would have left that alone. So now I see that, it leaves it alone. So now it's going to select the inclusion. I'll select it, no exclusions, select the data. View my results. And there it is, properly trimmed. Not as crisp a trim as I had when I hand drew those, but it's a lot closer to being what the data really is. That's the extent of my data. And you can see the triangles actually got trimmed along that line instead of having them erase along the line. Okay. So those are the basics of that. Now, let's talk about one other thing here. Let's go to view and thaw on all layers. And then let's go back to view and freeze layer by pick and turn off those white lines, which were those 3D break lines. And you may say, well, hey, I've got a contour line map. How about I build a surface and read the contours, use them as break lines? Well, you can do that. But here's what happens. And pay attention up here. I've got this contour line that comes in here, 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 and it's hitting that wall. This one goes to here, and then it's out here. Okay, but remember when I used the white lines for the 3D lines, there was a line along the bottom of that wall and a line along the top of that wall, and that formed that nice loading dock area. But if I don't have that, and if I say to myself, well, I've got a contour map, I'm just going to build a surface out of the contours and the points, which you can do. But here's what happens with that. Let's go to surface, triangulate and contour. And this time, right triangulation file, let's select. We're going to call this EG-BAD-2. And we'll go ahead and use our inclusion, no exclusion. Select all of our data. Ignore our little error. Okay, it didn't give us an error this time. But so now we've built a surface, and if we look at it, we're going to think, hey, good job, I built my surface. There's my ponds and all that. But look up here at what a mess happened along that loading dock. And where are my curbs? You know, I can sort of see where they are. I've got all of these jumbled up messes. And if I look right in here along my roadway, I get these stair-steppy looking things, okay? Same thing coming down this side. Now I'm going to go over here to my controls. I'm going to grab that little light source and drag it around to change the shadows a little bit. And you can see the difference between that surface file. And if I go back to my model tab, and I'm going to look at my EG Good 3. And I got to come back and turn that off and then back on. It does something goofy with the colors there. So now look at the difference along this roadbed. When I'm using my good ones, where I use those 3D lines, I can see these edges are nice and crisp. But if I turn that one off and this one back on, you see those stair steps? That's because what happened when I built this surface using these drawn contour lines, it formed triangles across those lines. In fact, let me show you that with my 3D viewer. I'll spin this up and look right in here. I'll put that model, that surface back on. So you see what happened is in here when it comes around, reading all the little vertex points along those contour lines and starting to form triangles. It gets here, for instance, right in here. Let me. Yeah, see right in here. It starts to form triangles. In fact, let's turn that off and you can see the triangles that form. This green contour line that comes up here. Sorry, this, trying to get it to show. All right, this bright green contour line that comes up here and then turns back here, and this dark green that comes here to here, it formed triangles. From this point, it could look across and see that point. This point could look across and see that point, and then it looked down and saw that point. So really what happens right in here? Turn that. Yeah, so what happens right in here in reality? It formed a triangle from this edge to this edge, and that's exactly the same elevation. Same thing from here to here. But on the ground, we know that it, let's say this is 100 and this is 98. It goes from 100 up here in the peak, it comes down here to this at 98. So right in here should be 99, but it's not, it's 100 because it goes from here to here and here to here and here to here and here. So that's 100 all the way through here. and then it drops to 98. And now it stays 98 all the way down here, when really it should be going from 98 down to 96. So 97, it should be in here, but it doesn't do that. Now, same thing here, you can see from this one, let's call that 94 to 92. So 94 down to 92, except it allowed 94 to look across and see 94. So what would I need to do if I didn't have those nice white break lines? All I had were contour lines. What would I have to do to be able to use this correctly? Remember our idea of break lines? Remember we said we had break lines that we needed to draw in the curb edges and all that kind of stuff. So I would need to draw a line, a 3D line from that point and that elevation up to this point and that elevation, up to this point and that elevation, and this point and that elevation, and finally down here to this point and that elevation, and say that is now going to be used in my data to keep this triangle from forming from here across to here, and from here across to here and across to here. It has to come down and it hits that line and can't go across it. It can't see the other points. Okay. I'll show you a real quick way of putting that in. I'm going to hide these edges right now. They're just at 0, but I want to get them out of the way. Same thing here. All right, so to be able to fix that, I need to draw a 3D polyline, and let's uncheck prompt for elevation or slope, and we'll put this on VTopo break line dash from contours. And I'm going to go from here to here. I'm just snapping to those endpoints. All right, so we'll use that. Oh, let's come up here and do another one. All right, that'll be sufficient. Let's build another surface. And this time we'll keep it at that same bad 2. Say, okay, yep, overwrite, select the inclusion. And the first of all, what I might want to do is I'm going to select just that data and view it to make sure that I got elevations on those white lines that I just drew, and there they are. So they're good. So I know I didn't accidentally go down to 0. Okay. So if I triangulate and contour, and this time I'll change the file, call it EGBed3. I'll select the inclusion, no exclusions, all data. And now when I view that, whoops, let's view this and add the surface. So now when I add 3, come back and toggle the triangles on and off. Now you can see in here where I drew that break line, notice the triangles did not cross it So right in here, this elevation doesn't jump across and see that elevation. It has to go down to that point in right there. Like top of the triangles, you can see them. See, it went from here down to here and then back up. Same thing here, down to here, and then back up. No triangles connected directly across that. Okay, so it modeled it correctly in those areas, but notice I didn't do them in this area or over here. So what that should tell you is that if you have a bunch of data, if you get in from somebody a drawn contour map, and that's all you have to build a surface with, you can do that, but you're going to need to put in these break lines. And again, we didn't do it up here where we should have to get that loading dock. So you might have to do some data conditioning to make that to make it model more precisely. And here's another example of how you can look at that. Let's go to the profiles menu and choose quick profile. I'm going to use a surface file as my source. I'm going to use two of them. I'm going to use for my first one, bad 3, and my second one, bad 2. I'll say okay. And now it says pick a starting point. So I'm going to go from here into here. And be done. Now you can see the one surface that I chose, that I said my surface 1 was the one where I drew in that break line. And the red line in here, let's do a, let's make it like this, a 10-time vertical exaggeration. So everywhere that I put the break line in, the surface modeled correctly down that slope. But where I didn't, notice it looks like a set of stair steps, right? So now the ramifications of all of that are this. If you don't have the break line data and you have to use contours, you need to put those break lines down the noses of those contours if it is important to not have those flat areas in there. Okay? And it usually is, because that's going to throw off our volume computations. So I'm going to, I'll get rid of those for now. But here's something to also keep in mind, particularly if you are doing this for a real quick takeoff to get some quantities. There's no need to really worry about doing that, because that's going to be my existing ground. And yes, it's going to be stair-steppy looking. But if I did, let's do that same thing from here to here to here. And we'll give it 10 times. So what's going to happen is this, is that, yeah, it's going to give me results that are too much right in here. But in areas like up here, they're going to be too little. See, really, where that should be is along that nice average line. So on the whole, when you're computing large areas for volumes, even though you haven't put in those break lines and you get these stair-steppy looking profiles, in the surface, on average, they will tend to balance each other out. Areas that are too much are going to sort of balance with the areas that are too little, so that the volume in between the two resulting surfaces is going to tend on average to sort of settle in on that on the correct median value between those two conditions. So again, using a little bit of judgment as to what purposes you're doing. If I'm trying to build that though, so that I can use my excavator to go out there and grade that road subgrade, I don't want those stair steps. I have to model that correctly, or it's going to, if I were to try to, if these were my finished contours and I'm trying to model those, if I get those stair steps, when my bulldozer goes down that edge of that road or my grader, it's going to chatter that blade and knock my driver out in the road, and the bulldozer is going to run over him. I'll have a lawsuit on my hands, and there you go. So just always use your judgment as to what it is you're trying to get out of the process. So when you need to fine tune, and those are some of those techniques. We draw 3D polylines. There's a couple of other things you can do. You can actually draw a 2D polyline, edge to edge, and then do things like, add a vertex, add another vertex, say up here somewhere. And so you can get it to where they're mostly close. All right, but now it's 2D, so how do you make it 3D? Well, you look at our 3D data menu and you want to convert a 2D to a 3D, and you're going to do it this time by screen entities. Give it a tolerance, ignore zeros, extrapolate the ends, keep the existing. I'm going to put this on that layer. I'm going to select this polyline to convert. And now select the surface faces, lines, and polylines, the things that I want to try to intersect and read the elevation of. So I'll just select all of those, and it converted one polyline that had 25 intersections. So that now, combined with these, has been created. Now, obviously, see, I would normally get those nose points. I wouldn't let it jump across. Okay, so, I might draw it as a 2D so that when I then elevated it, based on where it crossed the contours. In fact, let's do it a little more precisely. If I draw that 2D polyline, and I'm going to say start up here, go from that nose point to that nose point. These are all looking okay. I haven't crossed anything yet. I'll just keep coming down. Now I'm doing it as a 2D first for this reason, because if I'm drawing it as a 3D, which works okay here, but when I get into areas that I need to adjust, if I need to put in some extra points, those points become 0 on a 3D polyline. So I'm going to do it like this and show you what we're going to do. I'm going to get to where I go around a curve here. So there we go. Here we go. This will illustrate it. And then up to this one. All right. So now this really doesn't go from here to here. It goes around this curve. So I'm going to need to add in some vertex points. Whoops. There we go. Sorry. All right, so now it's a little more curvilinear. I'll do the same thing right here. Come up to this point in the middle. And I'll do the same thing here to go out here in between that. And that'll be fairly well. I'll assume these are all okay in here. Now, because I've added those extra points, even though I want to do this by screen entities, when I say select it, so I'm going to select this one. No other ones, I'm going to let it look at everything in the drawing. And now look what happens in those areas where I added this. If I look at these vertices, I'm going to hover the vertex. I'm going to look down here at my coordinate display. And I see that it interpolated between, see, if I'm at this one, it says 1294. This one says 1295. So that one says 1294.5. There's 95.7, 96, 96.12, 96.23, 96.40. So see, it's coming back up. There's 97, 96.86, 96.65. So it interpolates around all these points. But what's nice about it is that when I look at that in 3D, I can see that it went right down those contour edges. And right in here, it went right around that edge in between those contours and connected those up. So if I look at that one again, ZG-band 3, select this, no exclusions, build that. And now look at that surface. I now have a nicely defined sharp edge down those contours. Messed up some of that in there. But you can see as it follows around this outside edge, I don't have those flat triangles. Okay. Now, one final trick that may help a little when you are doing a surface from drawn contours only, and you don't have time or the inclination to draw those break lines, is when you triangulate and contour. This time I'll make one more file here. Notice this right here. There's a whole section right here that says adjustments for source data of contours. So if you're using contour lines to make your surface, you can do certain things here. You can tell it to minimize flats. Now it's not perfect, but you can see the improvement. Whereas we had a lot of those stair-steppy looking triangles. Now, even all the way up to the edge, that worked out pretty nicely in there. Still got a few of them over here on this edge that you can see like that. So it didn't really help it here a whole lot, but it helped it over here on this side pretty significantly, even all the way back beyond where I had drawn the line. Okay, so that can help you some, but it doesn't make it perfect. So even though when I just ran that command and it came back with no error messages, resist the temptation to say, oh, good, everything is great. Always, always go back and view the resulting surface and make sure that you've got, see, there's that nice curb along that sidewalk. I've got this nice loading dock there and there. So evaluate this stuff, use your eyes and see if there's a problem. Now I could look at this and I might say, well, maybe there's a problem right in here. You know, I might want to go back and fix that. Okay. Or maybe that's okay, or maybe I don't care. Maybe it's not of any vital concern and I'll just live with it. I might want to fix that. And I would do that by going into that original drawing and start drawing in break lines if I need to do that. Okay. But get a sense of how that works.
Most of the things we get are just gonna be just contours. We won't get the 3D polylines.
Yep.
So how are you gonna get your curves in there to make your curves look right?
Well, you will, not only will you get the contour lines, you'll get them and you'll set the contours at elevation, but you're going to also get probably these drawn in the file. You'll have curves and such and building outlines and things like that drawn, but they're down at 0 elevation. So what you would do in a case like that is you would take that data and say 2D to 3D by screen entities, perhaps. Let's put that back on that same deal. And I'm going to select that curb, and let's say that curb there. And all right, just as an example. And now select what it's going to look at. So it's going to look at everything and read. So now let's take a look and see what we elevated, if it's going to be sufficient. So I look at it. And so now there I've created that curb, but it may or may not be correct. And you can see the difference here is that, all right, the curb looks sort of okay. This looks pretty halfway decent. But in here, I see the tops are a little inconsistent, right? If you were to compare that to what we saw with the drawn break lines, you would notice that those drawn break lines, it's an even, consistent distance. This, the only information it had was where it crossed that contour line, it set an elevation point. Where it came out down here, it set an elevation point. So when we told it to elevate based on things it can cross and see, that's the only data we have. And we could take a look at that and see, all right, well, maybe we have to disregard one of those and create the other part to it. And we may look in here and say, well, it hits the face of the curve right here, comes out at the top. I may or may not be able to tell which one's a better one to use. Those look okay there. but somewhere in here, like this one crosses. See, this one hits here, but then it crosses here, and it really should be outside of that. So I'm going to say, I'm going to take this one and throw it away. And now let's say I know that's a 6-inch wedge curb. I'm going to use this other command called 3D data, 3D polyline utilities, offset 3D polyline. I'm going to choose this method of being by interval, and I'm just going to put this on that same layer. Then I'm going to select that polyline. Oops, I'm sorry. Say okay, and I'm going to answer the questions. Now, the horizontal offset amount I'm going to use is 1/2 foot. And the vertical offset amount I'm going to use is 1/2 foot. Notice it can also be done by slopes and percentages and degrees and all that. So I'm going 1/2 foot over, 1/2 foot up. And I'm going to take this polyline and I'm going to put it over there. Okay, so now if I select those two and just look at everything in context, now you see how I've created, I kept one of them as good. I kept the one that's down at the face of curb. And I offset it 1/2 foot horizontally, 1/2 foot vertically, all the way around the feature. And it's consistent. Now you may get some slight inconsistencies like right in here, where this contour doesn't wrap correctly. But there's not much you can do about that if what you want is the curb to be modeled correctly. Now you could, let's take a look at that one. We'll just keep it bad 4. Okay, we'll select area inclusion, no exclusions, select everything. And we'll exit that and we'll take a look at that surface. And now I see down here, the resulting surface is pretty rough right in here, but I got my curb looking okay. So I could do some things like, let's say, remove a point. Let's say that point, maybe. And then, so I'm trying to, whoops, that probably was not the right thing to do. Let's add a break line from here to here. So it healed that back. So I take out these little weird high spots. I'll leave that one in. Oh, let's get rid of it. No, I took out the wrong points, but you get the idea. It's what I'm really trying to do is sort of shape my way around that feature and sort of repair these things that I know might be caused by some potentially bad data. There's another, maybe a bad point in there. Now there's a place where if we put in a break line from here to here. See what that did when I put the brake line in? So there are ways, again, remember we had that retaining wall? If I put a brake line, say from here to here, oops. Let's do it from here to there. Get this positioned around so I can see it. And then let's go from there to there. And then we would do the same thing up here for the top of that line. They go from here. Here. It's too far. Let's see. At the bottom.
Did you drop your drawing on top of it to see where you want to put your brake lines at?
Yep, sure could. Come back here and we'll say add some entities. And it might be easier if I turned. But the problem is you can't control the order, the stacking. We can't control that. I would need to sort of know where those lines are. I can't really tell. I see right there along those contour lines. That's a contour line across the top. So you could maybe add a brake line from here to here. There we go. And then yeah, so say, and then, you know, you would come in here and tweak these things here, maybe. Add a brake line from here to here. I don't think it'll let me, it will. Okay. And it's about as good as we can really fine tune. Yeah, so whatever information you may have that will help you set these things up. Let's see, go from there to there. All right. So, so those are some of the techniques you can use to sort of fine tune Let's see, maybe add a break from there to there. Let me from there. I've already got one in there, so. Now there's a case where I've got this face comes down here and then there's a flat triangle in there. So if I add this break line from here up to here, see, it reshapes that so it doesn't do it that way, but it does it down here and then up here. So maybe you instead wanted it like that. Now that's not going to let me do that because I've already got one I'm trying to cross. So, it's not a perfect situation, but again, now if I say exit, it wants to know if I want to save the changes, I'd give it a new name and I would do that. So if you don't have that, and if all you have are the contours, then you need to really look closely and decide what it is this is telling you. See, I could look at this data and I would see that this set of red lines is actually, well, I can tell from the contours, hey, that's a wall. So I would say 2D to 3D by screen entities. Select those two. That's a closed figure, that's fine. And so now it's drawn that. And if I take a look at that and see what it looks like in context in my 3D viewer, I look at that and I say, oh, okay, that would probably model pretty nicely. I would then go back, triangulate contour, and it's an EGBAD4. Select this, no exclusions, all, oops, no exclusions, then all. View that surface this time. And now you can see it modeled it nicely. See the contour or the triangles formed along the edges of that wall instead of allowing the triangles to jump out, across from the top out here into space like it did with this one. See, that allowed these points up here to jump down and see those ends of the contours and such. But that helped control that considerably better. Okay, and then we had the same deal with their curb over there that we elevated. So sometimes you're given just the contours at elevation, maybe, but you're generally given things like, curbs and buildings and such like that in your site plan, and they're at 0 elevation, but you've got to elevate them, and you can elevate them not, you don't have to know the actual elevation, you just have to see that they cross things that do have elevation and tell it to read those items and set elevation points along the way to create those. And then once they're created, you can do things like use this elevation editor. And if I look at that, then I see that this is a figure around that curve, but look how in my little profile view over on the left, it's got some potential issues. Like I go from there to there to there. So it interpolates all the way down to that point. But if I uncheck you see what, if I'm here, it's holding that elevation. It goes to here and holds that elevation and then to there and holds that elevation. But if I uncheck, let's see, where's this next one? All right, so 26. So if I go from 9, so if I uncheck all the way up to 26 and then uncheck that, you see what that did right over here? It straightened out that kink in it. And then I could see there's a held point, there's a held point. Now you would have to know, see there's 42, so let's say maybe these, you would have to know that that's a valid edit. What I'm doing is releasing the elevations there. And the only way to find that out is to, look at this stuff around as it goes around these edges and make sure, because in that case, this outside one has this elevation from that contour, but it doesn't see another elevation till it gets to that contour. So is that valid? We hold that and we hold that. Well, that's probably valid. And then it does the same thing, but as it goes around this curve, it hits over here. So it goes from that elevation all the way around to this elevation, but we don't know that that's necessarily linear. Okay, but sometimes that's the only assumptions that we can make. Okay. It's a good question though. Any other questions? We're going to take a break here in a second and give you time to shake the cobwebs out of your head a little bit. Everything good? All right, it's almost 3:20. Got a couple minutes ahead of time. Let's pick back up at 3:30. And then we'll talk about some of these other tools to get those surfaces modeled. And a couple of the things with the takeoff method or the SiteNet method. Okay. So I'll see everybody back at 3:30. I will stop the share and I'll pause. Okay, I'm back whenever you guys are. There's Alex, Jason D, Jason F. Okay, so a little bit of review, if we can sort of try to encapsulate all of this information, is that surfaces are built by analyzing the data that we have selected, and it builds triangles between all of the point data that it can find. For instance, individual points, as well as the vertex points along polyline data. And it creates triangles. If I can, let's draw a triangular mesh. So you can see where the triangle is formed, and it is between, let's select all of these and then put them in the back. So you can see that everywhere it formed a triangle. Now, this was not drawn with the contours. Let's turn off contours a minute. So you can see that these triangles formed everywhere there were points. And vertex points along the 3D lines. Let me get those sent to the back. Uh, I guess it was just a line. All right, so, but, so it sits on every point and it looks around itself and it tries to find either vertices of these lines or other points. And if it encounters something like right here, these are the 3D the 3D break lines along those compiled break lines. And like we saw down here along the edges of the curb structures. So it keeps these points from looking across those break lines to other points, so the triangles can't form across those. So that's what is going to govern. Here's, for instance, those curb lines. So that's going to govern how the surface is modeled. So remember, that was the face of the curb around here, the top of the curb here, and it had all of those vertices around it. And it drew the triangles again from this point out to there, and that point was a vertex point in this line. Same thing here. So it goes from that point, found a point here and a point here. Well, it couldn't go across there because this line formed first. And it may be okay. These two may be close to being coplanar. So what we need to try to do then, and I'm going to now erase by layer. I'll select from the screen, I'll get everything on that layer to erase. So our job then is to find the data that we need. Let me turn back on break lines. So we need, all of this stuff to be set at the proper elevations to control how these triangles form. And once we've done all that, if we're not given this information, we have to create it ourselves or live with what results, say, from simply the drawn contours. So if we did something like, let's turn all the layers back on, and let's look at our set existing layers. I'm just going to use contours. And maybe points. All right, and then let's set a boundary polyline. And if we look at our site net method or takeoff method, we have nothing defined as design, everything from other. We told it use these for existing. And that's when we're taking it based on the layers to be included. I'm going to go down here and find this other one that I also used, move to existing. So now I've got these things that are going to make that existing surface. And the site net method, all I can do is make existing ground surface. And I've got, a bunch of crossings in here that you can zoom in and see where it crossed. Let's see here. Oh yeah, that was where this line and this line crossed and they were at different elevations. So, we would have to resolve areas like that. And if we look at, now remember our drawing file name is called sample from T3 Global. Well, I've got a surface down here now called sample from T3 Global EX, OG, and ZE. So there's my original ground. And that's it from the contours and from those little break lines that I made. But everything else, you see it still has those little stair-steppy areas. And remember, we modeled that wall over there, so that got fairly correct in here. It's a mess in here. So we have to look at that, and we also have to evaluate whether or not that's going to cause us any problems, because all we really may be wanting to do is to figure out how much paving goes in a parking lot down here. We're not going to waste time trying to fix a lot of that stuff. But those are some of the techniques that we're going to have to use when we elevate this stuff. Now, we talked about this site net area where we tell it which layers things are on, and then we just say, go and make it. But you saw from the surface method of triangulate and contour, where we can use inclusions, ignore zeros, and then we select the data, but then we have to name the surfaces and keep track of them separately. Okay. Now, putting boundaries on things, we saw from our draw shrink wrap entities. And we also saw where it was available to us in here. If we uncheck this, then it's going to do it for us. And we can choose setup and tell it whether to draw or not, what layer to go on, that sort of thing. All right, so we did points and contour lines this time. So now if I draw triangles for that surface, you can see how select similar and send it to the back. You can see how some of these triangles worked out okay, but in these little stair-steppy areas up in here, you can see, let me freeze off those break lines. So in some of these stair-steppy areas, you can see like right in here, we drew that break line, so no triangles came across the nose of that contour. But in other areas, like over in here, that triangle. See the selected line, let's make it a little heavier so you can see it. All right, so there's that contour line. And it built a triangle. Let's see, what is this one on? Oh, we put those in as well. I'm trying to find an area in here where we didn't get the contours to behave correctly. Let's see what's. Let me find. No, it's not. Not letting me select them. Oh, okay, so here's what's happening in here. These triangles form correctly in these nosed areas because of this setting. We told it to minimize flat triangles. Now, it did it in the SiteNet method because in our configure settings, take off SiteNet settings, we told it right here to minimize flat triangles. So if I had that unchecked, say, okay, we'll exit that, we will get rid of those triangles. And now let's go back to the SiteNet and just say make existing ground surface. Remember, it knew the boundary, it knew the layers that they were on, but it did not minimize the flat areas. So if we draw this one again, now you can see, for instance, on this contour line, see these triangles that formed across the flat area? So that triangle and this triangle are invalid. This one as well. Okay, same thing if you look at this contour line. Let's make both of those so you can see them. And look at how the triangles formed. It went point to point to point. And now from here down, this one's correct. This one's correct, but these are incorrect because we didn't have that setting set under Carlson configure takeoff site net settings to minimize the flat. So we do want to do that to minimize those flaps. And that kept those things from happening in there in that regard. But again, you can see when we do this based on that method, this site net or takeoff method, all we're doing is telling it the layers and we're telling it to go ahead and make the surface. We have to rely on those other settings to control these flat areas. But if you do it this method, triangulate the contour, you control all of that stuff by selecting the data that you're going to use to model. Okay, so there's your trade-off. And then you have to keep track of the file names that get created. Now let's erase to the mesh. Okay, so the whole process of building these surface files or modeling the terrain is we analyze what data we have and figure out the best way to really model what is out there on in our drawing or on the ground, any of that information that we have. Now, when we're not controlling what comes into us, we just have to, like in this case, we got it from these photogrammetry firms, but luckily for us, we had the 3D break line included. Sometimes you don't have that, and all you have are the contour lines. But you may have these edges, and you know that they're supposed to be edges, whoops. And then you would elevate those, maybe they're at 0 elevation, but you would elevate them based on where they crossed anything on the screen that has elevation, in this case, these contour lines. Okay. So that should give you a sense of, the fact that this isn't necessarily, push button, got my done button or my easy button. I just tell it and hit the push button and go. And there's a lot of people, a whole lot of people using this and any other software that models surfaces that they'll do that. They'll build a surface, they don't get any error messages, and they'll just go on and work with it as if it's correct. And the difference would be between, something like this something like this. So you've got that modeled nicely, or it's not. So, do your best, figure this stuff out, but use that 3D viewer to help you figure out how this is done. Now, a couple of things that we could have done, and some people prefer, is that instead of using this 3D viewer, they would just do something like when they triangulate and contour, they would turn on draw triangulation faces, or since we already have the surface, we'll draw the surface. And let's use that. Good, we'll draw it as 3D faces. And then once it draws, you can just view it in 3D on right inside the drawing editor itself. Okay, now I'm just setting some rotations. Now here I would need to set my view. Let's see, change our style to, so that'll color them in. So that could be of some benefit to you that way, but instead of having to do all of that, let's go back and turn that back to oops. Here, and then and also that puts a lot more entities in the drawings when you draw this stuff in there, and we don't have to, we can simply do our editor or our 3D viewer rather, and we can look at it all in here with all kinds of controls on how to spin it around. We've got other things up here like we can set the color by elevation, which gives us a good indicator of relative elevations. We go from blue to green to red, and those colors are settable on the settings tab. Set your colors, okay, right here. So other ways, this is another good way to look at our data to see if we've got something that's maybe sitting down at negative 10,000 feet elevation. It will show up with these numbers and we'll see it. You can do things like displaying a bounding box. So you can get a look at that. Turn the color by elevation off. You can just see the regular colors. But if you had a surface like this and the box was way down here and you had some bad triangles that formed, that will show you really quickly, where you may have some problems in the data, and then just use that to go back and fix your data. So get familiar with this viewer. It's going to help you evaluate what we have and figure out what's our best approach to making our data work. Okay. Let's see. And probably about what we're doing there. Now, the other idea that we want to look at, a lot of people do this automatically. They always draw these contours, okay, as part of the process of building the surface. So you're constantly drawing contours. But I think the better approach is that we just happen to have contours delivered. But if we didn't and we wanted to see where they were, we could turn those on. But anytime we have built the surface, we can always go to the surface menu and say contour from a TIN file, triangulated irregular network. So I put that on. I'll uncheck some of this. We go to draw the contours, turn it on. 2-foot interval. I'm not going to label anything, I'm just going to draw them. And so now we see our computed triangles compared to the delivered contours. You can see they're close. There's ours. There's what was delivered. Okay, so you can use that as a way of checking the work, see how well it modeled. In this case, we have that wall, for instance. We actually generated the contours They did not, they just clipped them. But that's another good indicator that we modeled it correctly. But when we look at those, compare them to what's showing on the ground, it looks fairly close. All right, so there's all kinds of evaluation tools. A 3D viewer is by far the handiest and the easiest. You've got on the profiles menu this quick profile where you can use surfaces or screen entities, for instance, and you can draw a little crossing line and see how it climbs up those contour lines. All right, so use anything and everything that you can to help you determine what the best data is to use to build our surfaces. And it's especially important when we get into design surfaces that we're going to be using to build with on our machine control. And by the way, the only real thing that sort of makes it machine control is on our surface menu. You've got this import export. You can export a TopCon or a Trimble surface file. And other things, if you're using, you can export a land XML file and use that to go into like some of the Leica controllers, that sort of thing. But the foundation to all of that is you've got to be able to build that surface correctly. Okay, so let's take a look at some of the things. What happens when we have a PDF file? So I'm going to go ahead and close this drawing file and not save it. And let's choose a new drawing. We'll go to the wizard here. And I'm going to give it a drawing name, and I'm going to call this one let's see. I'll just go to my folder. I'll call this one class example 2 or 3, whatever you want to call it. I'm going to set it up to be a 20 scale drawing. Oh. Take my default from that, take my default from that. Now I've got an empty blank drawing. But I've got a PDF file that I need to bring in and model into my surfaces. So let's go to File. And you might think it would be on this PDF menu, but that's just to output or to attach an underlay that you can draw over top of. We don't want to draw it. We want it to bring it in for us. So we're going to import, and we're going to just use standard import. Now, when this comes up, we're going to go over here on this right-hand edge where it says files of type, and we're going to come down and choose portable document format, PDF. Now, we're going to look in this examples 4 and look at this file called Harmer Permit Set. And notice there are 10 pages in there, and you can sort of get an idea of what is available by scrolling through that in the preview if you've turned on your preview pane. If not, go ahead and hit open. It's going to read the PDF file, and it's going to do the same thing. It's going to tell you you've got all these different files. Now, this happens to be the existing conditions, and then this one is our, I don't know, site plan or grading plan, something. But if you look at this, we're going to specify our insertion point on screen. We will bring in, I don't need any solid fills, just vector geometry, true type fonts fine. Join line and arc segment. So if I've got lines that are blown apart, contour lines, for instance, but they're, the endpoints all match up and line up, I can have it go ahead and join them into a single entity. Now we've got a problem with ours because they're going to have gaps in them because they drew them as dashed lines, but that's okay. We'll figure out how to do that. And we will uncheck this line weight properties because it will take thick lines and it will create them as hatches. So we were going to turn that one off. Leave all these other off. Turn those on if you want. It's not going to have any effect. And we'll say okay. It wants to know an insertion point. We'll just click a point out here in space. And it reads it and brings it all in. There it is. Notice it's not even rotated with north up, which doesn't really matter. We're going to take a look at what we've got here. Now we've got, if I select this line, you see that's all supposed to be a contour line like this, but it's got gaps in it. So we're going to have to join those up together, potentially. And we see that that's on a layer called PDF C3D surface existing. But also, so are these intermediate contours. They're on that same layer. So I can't even, if I wanted to isolate just those contours, I do that and I see that I get all the contours, the index as well as the intermediates, which I can tell because they're different colors. Now here's one thing that we're going to use these color characteristics. If I look at this and I see it has a color of 118, 118, 118, this one has a color of by layer. So if I select, I'm going to right click and choose quick select. And I'm going to select from this entire drawing multiple entity types whose color equals. I'll pull this down and choose select color. I'll go to my true color box and I'm going to type in 118, 118, 118. And I'll say okay. So now it's selected all of my index contours, even though they're on the same layer as this other one. So with them selected, I'm going to come up here now and change the color to be by layer and the layer to be one of my pre-built layers called V-topo-major. All right, so they're there, but they've gone away in our view because we have only that one layer isolated. I press escape to clear everything, and I'm going to select all of this. And I'm going to change it to that similar layer V-topo-minor. It now went away. And I can come back up here and restore my layers so that everything's showing. So that V-topo minor is that gray color, V-topo major is that sort of purple color. Okay, so now let's isolate that layer again. Again, the view menu, isolate layers, or from the layers toolbar right here. So I'm going to isolate just that layer there. So those are my index contours. Now, what I need to do, because the gaps in the drawing means these are all individual pieces, I need to close them up. And you can do it by, you can manually draw them, or let's choose join nearest. Join nearest is going to let us do that with this information. And normally this comes in with probably about 1/10 of a gap. And I've got a couple methods. I can average the endpoint. So if I go from here to here, and if I average that endpoint, it's going to put a point right there in the middle. But it will change this segment to go from here up to that middle point, and from that middle point out to the other end. So it's going to change the shape of the lines that come in. I don't want that one. I could directly connect, which means it's going to just draw a segment across the gap. Or I could fill it with a radius of 0, so it would extend to the intersection. Again, I don't want that case here because that's going to possibly be the wrong thing I want. So I'm going to choose directly connect endpoints. And you can convert them to a polyline, join only identical layers, only the same elevations, etc., etc. So I'm going to say okay, and I'm just going to select these 3 entities right here, and we hit enter, and nothing happened. See, it said joined, whoops, said joined 0 entities. Now, why that didn't happen? So if you ever get that problem, go back and run that command again, which is right here on my polyline toolbar, join nearest. Also on the edit menu, join nearest. And I look at this up here, that gap, that maximum separation, that gap was too big. So if I say pick, and I just come down here and show it something that's at least big enough to cover that gap, and then say okay. And now I select those, and you see what it did. It's now a single drawn polygon. Now, the next problem you get into with something like that would be up in here. If I tried to join nearest, say, okay, and if I just selected these, now watch what happens. You see how this became a single line that went around, you know, from here, snaked its way all the way around. And that's not what I want with that. So I'm going to have to do something like this, that I make sure I'm getting the proper pieces. Repeat the command. And continue to do that so that I don't jump across this way. It's very much like those flat areas when we're modeling. Okay, so you see there could be some work involved in getting things to where we can model this stuff successfully. I'm going to show you something else that's going to be to our benefit here in a minute. So we would do that not only for the index contours, but then remember, we've got all those intermediate contours. We've got to do that too as well. Let me change the color assignment there for them. Dash topo. Major. Let's make the majors yellow. The minors will leave that color. All right, so I would then have to do that, and that could take me quite a bit of time to have to do. But if I look at, and if I go back and look at the PDF, I can see, well, this line out here, I actually brought it in as a have a dash line. That is our NPDES limits. That's our limits of disturbance, this line out here. So let's isolate that layer. And let's join nearest for that one. Making sure we're big enough to cross the gap. So there's now is our effective boundary. We'll restore the layers. And we have this that we can use as an inclusion boundary. Now I'm going to go ahead and offset that. I see that it's a 2D polyline with 0 elevation, so I can use a standard offset. I'm going to offset that using my standard offset command. Let's just say 25 feet. We'll go from there to there. So that's going to give me really the boundary that I want to be able to work within. That gives me a little bit outside my limits, so I can deal with that. You know, I might even want to let's see. Looks like my stream is all contained, you know, well, up here the stream goes to there, so you may want to make it a little bit bigger to incorporate some of that down the edges if you needed it. But what I would recommend is that we do this to, you know, I know that I'm not going to be working outside of this line. I went 25 feet outside of that with an offset, and that's going to be the extent to which I want to work. I don't want to have to convert all of these lines out here like I did and get this giant surface when my work is going to be contained here. So we've got a command now on the edit menu, and we're going to say erase by closed polyline. Now what this is going to do, it not only erases things that are either inside or outside, but it will also clip them off at that edge. So it prompted me to select the perimeter polyline. I'm going to grab that line. And these are the types of entities. I'll have them all on. I want to clip them. And I'm going to erase on the outside. I'll say okay. And the little progress bar down here is it's thinking. And now I've got just a few stray things. I don't know that there's anything there. Yeah, a couple of stray things. They're probably like 0 length polylines. Yep, 0 length polylines. All right, so there's a command I can use for that too. And it's on this lovely little, let's see, what is this? That's an ellipse. Only ellipse I've got. All right, so a bunch of 0 length polylines that are left over, they're really just, they're points, but they were polylines when it did the conversion. So if I go to my file menu and choose drawing cleanup, I've got a number of things I can do in here. And I'm going to hit the clear button to uncheck all of these. And I'm going to say I want to remove 0 length polylines, which is right here about a third of the way up from the bottom. Or fragmentary line work, anything that is within a 100th of a foot. I'll say okay. And it removed 27 things from here. I'll hit exit. Now I look at that. I zoom extents. I still got these couple of little ellipses down here that came from who knows where. I'll simply select them and erase them. So now I've significantly cut down on my work that I have to do. So let's go back and isolate the index contours. And now when you do your join nearest, and you give it a gap big enough, you can see it's going to go a lot faster for you. If you run into a situation where it leaves a gap, that means your gap wasn't big enough. So you would go through and like right here, that gap wasn't big enough. You could either set the gap big enough or simply draw from here to here. Join. Make sure you uncheck this identical layers. So this one to this one to this one. So now it's all one layer. So you repeat. Another place with a gap. There we go. And if you need to, you can select now the whichever one of you, I forget who said that you had the you've got AutoCAD. So you can just start drawing your selection, but in IntelliCAD, when you select things, if you type WP, that means use a window, but select it with a polyline. And you can just make sure, you know, as you stay in between. All of those areas, and it will limit it to that. So you get the idea. So you're going to need to do this for anything that you want to treat as a continuous line. Now, you don't have to create these as continuous lines. You can leave them like this. And when you build your surface, it's just going to triangulate across those gaps, possibly. But if you don't, it could allow something on this line to jump across that gap and see and build a triangle in there. So you want to try to close those up. All right. Now, and then of course you would need to do that for these as well. Okay, so, you know, it could be a bit of some work to try to do that. Now that's the elevation. label. And we didn't bring it in correctly when we did our import. What did I just do? Wasn't what I meant to do. Oh, I opened the file. Back over here. Instead of drawing files, make sure you say portable document file to bring this up. We choose that, and then we should probably have said invalid true type text as geometry. And then this way, I'm going to go over here and put it over on this side. And now you see it's, if I select oops, I don't want to select. All right, but you see, it brings these in, but this is actually a hatch. It's not a piece of text. But it's there, it's legible, so I could use that to set the elevations when I go back over here and set the elevations on that file. Okay. So you would do that. And once this is done, and once you've got, say, some of these contour lines set, to, you know, based on that elevation, based on that label, I'm going to go back and isolate this line again. Then what you would do to set these at their elevations, because right now they're all at 0. So if I select everything and try to view it in my 3D viewer, see, they're all at 0 elevation. So I need to get them to their right elevation. And assuming I've got all of these others made into solid lines. So how you do that is go to a 3D data, and you're going to assign contour elevations, and you can do it. We don't have contour labels, even though you saw those, but they were hatches. But we can do multiple in a series or do a single elevation and pick a bunch of contours that have that elevation. So if I say multiple in series, then what I'm going to do is I'm going to go every 2 feet or whatever the interval is and say, okay. Now down here, it's asking for a first point. I may say start here, and I'm going to go up to, well, let's say even here. And it says, give me a beginning elevation. Now that number is left over from the last time you ran the software. So maybe this is at 1020. Now, which way does it go, up or down? You know, this is going down. And boom, there they are. And if I select everything again and view it, you can see that I've got that's not, it normally would show me that. But anyway, it got those placed in at the right elevations. But if I zoom this out here and look at it in just in my, you see how some are elevated and some are not. So you have to keep looking at that to make sure you have things at their proper elevation. And here is where the SiteNet method won't allow you to do this, but the takeoff module will. And this is what I was talking about at the first of the day today. Under our settings, Carlson configure these color settings is, now I'm going to select all the polylines and set them to 0 again. So now they're back at 0. I'm going to switch to the construction module so that I'm running quote takeoff. And now I'm going to set existing, and I will set that layer for existing. I'm going to leave these unset for existing for right now. And I'm going to display, or if I look at my defined layers, I see VTopo majors existing, nothing designed, everything else is other. So if I look at my display, if I can find where it went. Oh, over here. I'm right now looking at existing and design, so I'm going to turn off design, but there was nothing to turn off, but I'm going to turn off other. So everything's going to disappear except for what I said was existing. And looks like something here has an elevation. Oh no, that's an arc. Convert these arcs to polylines. All right, so now I'm looking at existing, but if you remember, my setting said existing should be green, other should be gray, but if it has no elevation, make it red. So if I display other, all the rest of that stuff, which was originally shown, let me turn these all on for a minute. And it is now back to color by layer. So if I go to display, turn existing off, design off, and other off. Now when I display other is just going to be that gray. Well, except for those, which should be gray. Why is it showing as rough? Anyway, if I turn other back off, and I'm going to display existing. I think what's going on is there's something about the Zoom session that's not changing those colors for us. All right, so I've got my existing contours shown, but my elevations aren't set yet. So if I go back and elevate, assign contour in series, and I go from here up to here. My beginning elevation said was 1020. It's going down. notice now I can look at it just in general and say, and see which ones have been elevated without having to look at it in 3D. Now, if there's something else going on here. Automatic colors, assign colors by target. That's what was going on. All right. So now they become green instead of red. Now, if I show my other, they're all going to be gray. See how they turn gray? My design, which I don't have, would be blue. So I can turn this on and off and sort of control my visibility, and then also decide or be able to see at a glance the things that I've elevated, and then know I need to go from here and continue that elevation by contour elevations, multiple in series. And again, I went from there, can go across there. Now the last one it set was 998. So that's going to be 6. And it's, sorry. 6 going down. And so now they are set. Okay. And then you could even do things like this join nearest, where you can elevate 0 elevations when joined to an elevated item. So in that case, selecting all of these, we'll join it, and it now has an elevation here of 994. But because I didn't use a takeoff command to elevate that, it doesn't change its color until I go back and say update colors for set elevations. Okay, so there's a number of tools that the full construction module or takeoff product will give you that you won't have in civil. If I go back to civil, and now let's see, there is no SiteNet, there is no update colors. And if I just say display existing, I'll turn off. I'll display existing again. Come on, and if I change these elevations now, by updating the elevations from 0, there's no way for me to get that to show as green, because see, that's been set as green because it was determined that it was on the layer that was defined to be existing. Okay, but SiteNet doesn't give me any way to update those colors like the takeoff part did. So I would simply have to change that to green. And then once you're done with all of those, if you want to just select everything and change its color back to by layer, and you can go back to your original colors. All right. So again, if I turn everything on, set everything back to by layer. So again, you can see there's sometimes a bit of work to do and a bit of interpretation, like does this contour line do this? That one looks pretty self-explanatory. But in other areas like over in here where it gets really tight, you may or may not, where does this one go? Does it go to there, this one to there, this one to there, or does this one go here? This one comes here and this one comes here. So you're going to have to be able to interpret those things as you're working. All right. But now we've got a lot of this work that has actually already been done in that process, get it's a huge fire right now. Get my mouse to cooperate. Okay. So here you can see we actually had, they actually brought in a number of things. You see the blue and red contours are my design contours. My gray ones in the background, those are my existing contours. And we can model all that stuff. So we're going to open this file up tomorrow and use it, since they've already been elevated, to see how we can grade those elements and use them to create those surfaces for us. Okay. Questions so far? Anything may have occurred that you need a quick answer for? So, we're not going to take the time to sit here and connect up a bunch of lines that, run out of class time to do that. But you see the process that you have to use sometimes to get these things usable. But I would take that idea of that limits of disturbance, bring that in, and then you could do something like import, standard import, change the type. Now, don't forget to do that like I did. Change this again, or choose that again. And now this is going to be our, or maybe this is our grading plan. I'll say, okay. We'll come over here and click a point. And I see I've got a drawing sheet, but it's at a different scale. And that's another thing too, by the way. When you bring these in, you've got a drawing scale. Always check to see what, see that came in at 40 scale. So that one was okay. But sometimes if it's just an image file, that might come in as 1 inch instead of 40 feet. So you'd have to go out and scale with a relative scale to make it match. So now what we would do here is you would take this data, and you see that limits of disturbance is that same outline that we used before. So we could go to our edit, align, 2D align, and we will, let's go ahead and just align everything. And it wants to know a first source point. So I'm going to go from there to there. And then I'm going to go from there to there. And it says, do you want to scale? Because it's got a slightly different scale factor. So I'll say, yep, I'm going to scale it and rotate it. And we'll see what happens. Is now everything lines up at the right scale, the right offsets, and I've got another, I've got these drawn polylines. Now again, they're not elevated, but I could do that based on, well, if I don't erase everything, I could do that elevation by going through and reading the labels and setting the values to create the grading plan. That's, and then assign those layers to design. If I'm doing it through this SiteNet business, we'll set the targets by design. Set layer target for design. I would say, this one and this one. And let's say the road edges. So you got the building outlined as well, and then I would display design layers. Turn off existing, and I could work with that. In which case, that polyline for the road edge has not been elevated yet. But I would do that by crossing those screen entities, right? And so I would set my parking curbs all based on these contour lines, or if I had spot elevations shown. Okay, so there's some advantages to doing it both ways. If I look at other, then I can see if I've got, finished floor elevations or spot elevations on my curbs, anything like that. Okay, so a number of tools at our disposal. Okay, I'll save that drawing, but we won't use it any further. And we can. So that. Okay, questions at all? Everybody good?
Looking good.
Alrighty. If you think of anything that, any questions that have come up that you want to go over in the morning, we'll start off with a little bit of review and get a chance to ask some questions you may have. And we'll work on, the next stages and do some of the finer grading techniques, okay?
Excellent.
All right, so with that, I will stop the share and I'll stop the recording.